All right, guys. So, you are about to watch the tutorial for 8th grade math spiral practice part 2. So this is going to go over your spiral practice questions from 21 all the way to 40, and this is intended to help you guys prepare. So it's a random mix of problems. Hopefully I explained them well enough for you to understand and prepare yourself for the review that's coming up before STAAR. Take advantage of this. If you need to watch it several times, do so. If you need to watch it once, that's fine. But this should be the easiest way to help you review for STAAR.
All right, so which of the following is a rational number but not an integer? All right, so the good thing here is that we already have a picture of our real number system. So keyword is rational and then not integer. So if you remember how the real number system works is you can work your way out, but you cannot work your way back in. So for example, if you're a natural, you're also a whole, which also makes you an integer, which also makes you rational, which makes you a real. However, let's say I'm a rational. I cannot work back in to be called an integer. I cannot work my way back in, but I can work my way out. So let's just keep this in mind as you do these. So let's figure out where 4 lives. 4 would be a natural, which by the way is sometimes called counting. But 4 is a counting, which work your way out, makes it a whole, which is also an integer, which is also a rational, which is also a real. So notice this one isn't going to work because it is rational, but it's also an integer. So I can't have that. I need something that's rational, but not an integer. So if I go to -8, well, -8 lives over here in integers. So it's an integer, which also makes it rational, which also makes it real. And I already have an issue because I didn't want it to be integer. I want non-integer. So I look for 13/2, and that's a fraction. So the fractions live over here in rationals. And then just by the way, if you do 13/2, it's 6.5. So I could even say 6.5, and my decimals would live in the rationals anyways. So for 13/2, I would start off with rational, which is also real. And then that's it. There's nowhere else I can move to. So this one actually has the qualities that I want. It is rational, and it's not an integer. But then for the sake of checking, we go check D. And if you type in the square root of 6, so just to give you a heads up, square root of 6, notice it gives you a decimal that keeps on going in no particular order. It goes on forever in no particular order. So 6 is going to be referred to as a irrational number. And if I'm at irrational, so over here is the square root of 6, I can work my way out to real. But either way, this isn't going to work because I want rational, not irrational. So careful with the wording there. I end up going with C. All right, on the next one. Big problem. This comes out so many times. All right, sorry about that. I tried to pause it before the announcement, but it went on. All right, either way, what is the unit rate? So keyword here is going to be unit rate. You could even use pages per minute because that's another way to say unit rate. Now, you should know that there's another word for unit rate, which is going to be rise over run, which also means change in y over change of x, which also means slope. I want to say I'm missing one. Which also means rate of change. For the sake of this problem, this is what I need. When it asks you for the unit rate, you need to find the slope. So this problem could have been said, what is the slope? What is the rise over run? And they'd have been asking the same question. Now, one of the best methods I like, especially when you have a graph, is to use rise over run. When you do rise over run, it requires perfect points. I want you to notice that the points that I picked, they're perfect in the fact that they are on the line and the grid. Otherwise, you can't pick it. So, for example, if I pick this point right here, you see that's a very hard point to read. Okay, so another announcement, no big deal. Either way, the points you pick, you want them to be perfectly on the line and the grid line. That red point that I just drew, this isn't perfect. It's not on the grid line. It's on the line, but not on the grid line. So I want to be careful about picking that. Now, another thing to look out for when you do rise over run, it's any 2 points. But when you count, you do need to be careful with your scales. In fact, it's probably good to make note of what the scales are going by. On the y-axis, this is going by ones. However, on the x-axis, you should notice that it's actually going by 0.5s, or you could say halves. This is going to affect the way I count. So when I count rise, my rise is actually 3. And if I go show you here, 1, 2, 3. Now, when I do run, you need to be careful. A lot of people think it looks like 2, and it does look like 2. The issue is that my run is going by halves. So when I count that, it's really going 0.5, 1. So that makes me read this differently. So you do need to be careful with the scale. So 3 over 1 is just 3, and my answer would be F. Now, other approaches. And this is only one of many methods to solve this. Now, you could use 2 points. Again, it doesn't matter which 2 so long as they're perfect points. Let's say I decide to do change in y over change of x. This is really a formula. And if you use the formula, it'll also work. I like to label them before I set it up. I'd want to do y2 over y1. And I get the feeling this is going to be in the way, so let me move this. Okay. And the initial setup would be 12 minus 9 over 4 minus 3. You do want to be careful setting these up because a lot of people make mistakes. y2 minus y1 over x2 minus x1. The change in y over the change of x, which, by the way, this is on the formula chart. So we do want to use that when necessary. All right. Now, if I type this in, what's 12 minus 9 over 4 minus 3? It'll simply just give me 3. Now, here's how you type this in, just in case. So you type in the fraction, and I'm going to do 12 minus 9 over, it was what? 4 minus 3, sorry. So 4 minus 3. And if you type it in right, this will simply just give you 3. Notice it's the same answer, and it should be, because I'm just using different methods for the same thing. I prefer going to use the rise over run on the graph, but it's really up to you. Now, the ultimate backup method, and this is, you should do rise over run, but the ultimate backup method is to use a linear regression. Okay, this is probably going to be the easiest route. It comes out a lot. Use it as you need it. I'll go ahead and I'll explain those steps later on. It comes out several times. All right, and then we got this last one over here. So on this one, when you read it, you should have found the keyword to be that you're going to rotate this 90 degrees clockwise. Now, I prefer that you know your rules when you do this, but you could also go check a point. Since I don't have a graph paper here or a way of showing you a graph paper, I'm going to show you with the rule. Now, this rule says the following. Your original points will be, let me write this a little bit lower actually. Your original points, first off, when you do a 90 clockwise, or a 90 counter for that matter, you're going to switch them. So notice x and y will be switched. The way I remember exactly what's going to happen is I put a clockwise or a counterclockwise arrow through the top. So this is 90 clockwise. I'm going to make myself a clockwise arrow. That tells me the x will become opposite. So this first rule is going to be my 90 degree clockwise rule. And then just for the sake of having it, here is what a 90 degree counter clockwise rule will look like. So some people get these mixed up. So here's your idea. You have your originals, and what's going to happen there is again, you are going to switch them. But in this case, instead of doing a clockwise arrow through the top, I'm going to draw a counter arrow. And that'll tell me that the y will become opposite. So depending on which one comes out. More than likely that the counter answers will be one of the answer choices. But for right now, let's focus on the 90 clockwise. So here's what the rule does. I'm going to focus only on A and B prime. So let's focus on A and B. I'm going to get A, which the original one is 3, 6. And what I'm going to do is, according to the rule, I'm going to switch them. So I'm going to do 6, 3. Then, since I'm doing 90 clockwise, I'm going to make my 90 clockwise arrow. Then that tells me that 3 becomes opposite. So what's the opposite of 3? Negative 3. So one of my first answers is going to be 6, negative 3. And since I did this to point A, the new point is A prime. So I know that one of my new answers should be 6, negative 3 for A prime. If I check my answers, which is what a good test taker will do, you'll notice that B is out because of here, and then C is out, well, because of the whole thing, really. Now, you can't go and pick A until you've checked B, because the answer could not be there. So let's go check the next one. So let me go ahead and, just to be safe, I'll go ahead and move this. And let's go try the same work, but with B. So B is going to be located at negative 4, 2. Now, according to the rule, what am I going to do with it? Well, I'm going to switch them. So y, x. So it'll become 2 and then negative 4. Now, make your clockwise arrow, and that clockwise arrow says to make the negative 4 opposite. So what's the opposite of negative 4? In this case, it's positive 4. So my second answer for B prime will be 2, 4. So if I go check my answers, these look good here on top. Both of them work. My answer is A. And there you have it. All right, so in this case, the keywords are going to be dilated. And then this asks me to focus on the rule. Now, if you look at your answer choices, what I'm hoping is that you'll recognize the types of answer choices. Now, when I set up a dilation rule, what you should notice is that the word dilation means to get bigger or smaller. Now, one of the things I ask when I teach dilation is, how do you use the scale factor? The thing is, dilated is always tied into a scale factor. And how do you use the scale factor? You multiply with it. So it is used as a multiplier. Now, with that being said, let me go ahead and give you some more detail on this. The way a dilation rule is set up is scale factor x, scale factor y. Notice that I'm using the scale factor as a multiplier. Now, one of the things to do here is you can check your answers and you'll notice that 2 of these don't look like dilation rules. You should notice them to be B and, just B actually. B is going to be a translation. So that leaves me with the rest. Now, one of the things that you need to know is scale factor is used as a multiplier, hence the setup. Now, the other thing is that the scale factor, the way you find it is you do new over old. Now, one of the easier methods to do is to just check your answers. You could just plug it in and see what it gives you. That's another way to go. So here's the easy route. Let's say I focus on A. I know that original is 2, 7 and the new one is 4, 14. If I go and check A, all the x values and y values will be multiplied by 0.5. So what's 0.5 times 2? Well, that's 1. And then what's 0.5 times 7? Well, that's 3.5. That means that if I were to check A and I was to do 0.5 times 2 and 0.5 times 7, that would give me an answer of 1 comma 3.5. However, I'm supposed to get an answer of 4 comma 14. So I can tell you that A is not going to work. Now, if I go check C, which I accidentally showed the answer, here's what should happen. What's 2 times the x value 2, and then 2 times the y value 7? Well, 2 times 2 is 4, and 2 times 7 is 14. So by checking it that way, the answer is probably going to be C. I mean, it worked for that one. But let's just go and check D to be safe. So what's the 1.5 times the x value of 2 and 1.5 times the x value of 7? So if I go do 1.5 times 2, that's the first x value, and then 1.5 times 7, there's the y value, it becomes 3 comma 10.5. So this one here, notice that I don't get the answer that I wanted. I wanted to get this, 4 comma 14, but it doesn't happen. So basically, which is the only option I have left? C. Now, I do want to keep in mind, you could have done nu over old. My scale factor on C is 2. The way to get that would have been to choose a new coordinate. For example, I could have chosen 4 as my new. Notice it has a prime there on A. That's why I know it's new. And what corresponds to it as the old? Well, if 4 is my new, then 2 is my old. And what's 4 over 2? 2. So my scale factor is 2. And that's the only one. Now, I could have also done it with whatever other corresponding new over old that I want. So if I had chosen 14, for example, well, if that's my new, then the old would have had to have been 7. Either way, the new over old still gives me 2. So the way you can find the scale factor is new over old. The way you use the scale factor, that's what I did with the answer choices, is to simply just multiply with it. So I can just check my answers that route. All right. On the next one, if you have a calculator, it should be pretty easy. But it says, which of the following real numbers does not lie between the square root of 101 and 123? So not between. Okay, just keep that in mind. So what I would do is make sure you got your values for the square root of 101, which is 10.04 and then ... And then the square root of 123, which is 11.09 ... It goes on forever. Now, go and put where your answer choices live. 9.2 is before 10.04. 21 over 2, change it to a decimal. What's 21 over 2? Or 21 divided by 2? 10.5. So that one, in turn, can be read as 10.50, which would be here at the middle. It's still going to be in between. And then the square root of 115, if you go type that in, what's the square root of 115? So what times itself gives you 115? That'd be about 10.7, 10.72. That one is going to land before the 11.09. And then I got one more to check, 11, or 11.0. which is still really close or before 11.09. So the only option that I had there that's not between should have been enough. Easy to check, easy to do, so long as you guys got use of your calculator. All right. So this one has a lot of reading, so I'll just start with the basics here. I want to find the rate of change. I want to find the slope. There's a lot of reading going on here. So when you write an equation, I'll remind you that there is an mx plus b form. And when I say the m, that is the slope, which is my rise over run, which is my change of y over change of x, which is the same formula, which is, there's a bunch of different words for it. Okay, now, key words for slope are words such as per, each, and every. So whenever you see those words per, each, and every, that is a hint for the slope. So when she says she makes the same deposit every month, that's the hint for slope. And notice your answer choices. They say per month. That's a unit rate, which is the slope. Now, here's where a lot of us miss out. Another word for the B, the y-intercept, the keywords there are initial value, starting at. When you see those are the y-intercepts. The initial value, and a lot of people forget that. It could be at the beginning. You could be seeing words like initial fee or starting with, something like that. In this case, it says she opens it with $100. That is my y-intercept. That's actually where I start. So when she opens the account, she has nothing. She has no months. She does have something in there, though. She starts it off with $100. Now, after 4 months, she has 200. After 6 months, she has 250. And then that's all it gives me. Now, I'm hoping you all will see a pattern there. I don't know if y'all can tell that every 2 months, so if I do 6, there should be another 50. And the pattern there is to notice the change in y and the change in x. The change in x is really easy. It's going by 2s. And what's the change in y's? It's going by 50s. Now, I'm hoping you all can see that. If every 2 months it increases by 50, then I want you to be careful because look at the answer choices. A says 50 per month. My table says 50 every 2 months. It's not the same. If it's 50 every 2 months, in reality, when you simplify that, it's $25 per month. This is the way you should look at it. There's a lot of reading. There's a lot of keywords for when you're making your table with slope and y-intercept. A lot of people forget the y-intercept of 0, 100. But keywords for y-intercept are going to be initial value starting at, maybe like a starting fee or something like that. Okay. Okay, so on the top it says triangle PQR is a dilation of MNO. So that would mean MNO is the original, and then PQR is the new. All right. I'm looking for something that is not true. That's the obvious. So I want something false. Now, every time you have these true or false questions, go through all the answer choices and prove them all. Okay. That way you don't accidentally miss up that you were looking for false or that you were looking for true or whatever it is that you were looking for in that case. So let's start off with the keyword. It's a dilation. You all should know that it means to get bigger or smaller, or I should be using enlargement or reduction. Now, dilations make shapes that are similar, meaning same shape, different size, and proportional. And you get a lot of questions on these. Every time you have to set up proportions, and when I say proportional and set up proportions, you got to set up fraction equals fraction, something like that. Hint, look at your answer choice D. Okay, there's a lot of times where you get those. All right, but either way, this is something that is true. Dilations make shapes that are similar and proportional. All right, let's look at A. The measure of angle M is the same as the measure of angle P. So, in a dilation, do the angles change? The answer, no. There are no transformations that will change the angle. If the angles never change, then do they stay the same? As far as M and P go, they are corresponding. They're the same spots, different location. M corresponds to P. They are the same. A is true. Now, B, the scale factor for the dilation is true. Well, the scale factor tells me how many times bigger. Pretty much says it. The original is M, the new one is twice M. Did the new one get twice as big? Yeah. So that is also true. Now, it's between C and D. Now, it's kind of easy to tell that when I talk about PR, I'm talking this spot. Is it true that PR is twice the length of MO? Well, if B is true, then it's kind of easy to say that C is true. And C is true, actually. Now, I want to put focus on D. Now, even though I know that D must be the answer because the rest have been proven true, I want to go through it because there's a lot of ways to set these up and we run into so many issues here. So how do I prove D? Okay, well, here's one way. Let's use some fake numbers. I'm going to refer to my old and new as the big and the small and the big one. Okay, now, if my small one is 3 and 5, and I just gave 2 of the sides and I made up those numbers, okay, but if they are 3 and 5, then my bigger one, okay, should be twice as big. So instead of saying 5 for the new one, if it's twice as big, I should be able to say 10. And if 3 was the small one, then the big one should be twice as big, which is 6. Now, what I want to do is I want to set up the fraction I see there. The fraction equals fraction, or really I should be saying the proportion. Is that proportion set up correctly? Well, when I refer to MO, I'm referring to the 3. When I refer to MO over PR, PR is the 6. Now, I want to know if 3 over 6 is equal to, on the other side I have PQ. PQ is the 10 over MN, which is the 5. Is this proportion true? Now, I'm hoping you guys can tell at a glance, but here's the simple thing. If I simplify 3 over 6, that's 1/2. And if I simplify 10 over 5, that's 2. Is 1/2 equal to 2? No. That proportion is set up wrong. In fact, one of the ways to check is that you should have some type of constant pattern, like small over big or even big over small. But here's the easy thing. Can a regular fraction, 3 over 6, ever be equal to an improper fraction, 10 over 5? No. An improper will always give you something bigger than 1. And a regular fraction will always give you something less than 1. So D is false. And, well, that's my missing answer. All right, moving on. Number 2, these are pretty easy. I do, however, recommend that once you work these, get to your formula chart. Once you find the keyword, you need to use your formula chart. So what are the keywords on number 2? A lot of people say investment, invest. No, the real keyword is going to be simple interest, because that word is going to be found on your formula chart. Simple interest, the formula is right there. It's I equals PRT. Now, on our formula charts that we use, we have those extra things. Just remember, if you want to use this on your STAAR, you have to memorize. You're going to have to learn what all those things mean, and then you'll write it in when you take your test so that you can use that for your advantage. Now, let's use I equals PRT. Now, there's a little trick here at the end that often will confuse us, and I'll cover that. But for right now, let's make sure we know what P, R, and T are. So when I say P, P is the starting money. So what's the money that's starting with here? Okay, it's 15,000. When I say R, notice that the R here, I don't know if I can, yeah, more or less, that's what I'm talking about, is por ciento. A lot of people forget that they have to use this as a decimal. The easiest way to change a percent to a decimal is to do divided by 100. So what's 2.5 divided by 100? 0.025. And then T is the easiest, how much time. And all it says is each year. So you should interpret each year to mean every 1 year. So T is 1. Now, go and sub in the formula. Go plug in P, plug in R, and plug in T. It should look something like this. Now, what is I equal to? By the way, what does I stand for? I is the interest. This particular problem is solving for the interest. Sometimes I get this mixed up with this. You all need to make sure that when you're using I, you're solving for the interest, but when you're using A, you're solving for the total amount. In this particular question, it's asking me for how much interest. It's asking me for I. I'm going to get the answer for I. So all I got to do is type that in. So what's 15,000 times 0.025? Let's go ahead and go to our calculator. So what's 15,000 times 0.025? Don't forget the 0.025. And then times t, which is 1. And you end up with this much. So how much interest is this making? It's making $375 each year. And since I asked you for the interest, and I have the interest, my answer is complete. What you want to watch out for is if they asked you, what's the total amount after a year? Then that would change what I have to do. Because if the total amount was $375, I'd have an issue. If I put in 15,000 and at the end I only have 375, there'd be a problem. But depending on the question, whether it's asking for interest or the amount, it'll change what you have to do at the end. In this case, I have the interest. It asks for the interest. I am done. All right. So, which of the following is not a function? So every time we do these, label all of them, but you need to know what a function is first. So the definition that we use is where every X kid has only one Y mom, and you're supposed to tell me that X kids cannot repeat. You kids cannot be born out of somebody else. But your Y moms, they can repeat, meaning somebody else can call your mom their mom. Now, A is the only one that this structure of X cannot, Y can doesn't work. When you do A, you have to do something called a vertical line test. I can tell you A is a function, and if I draw a vertical line, it's just straight up and down. The way you pass is that you can only cross once. And anywhere that I draw a vertical line on A, it will pass. So I know A is a function. Label all of them. I'm looking for not a function. Sometimes people pick A because, oh look, I found the function, I'm done. If you go and check all of them, you won't make that mistake. So if I go check B, X cannot repeat. So I really just got to check my X values. 1, 2, 3, 5. They're all different. X didn't repeat. So I have a function. Now, if A and B are both functions, then that should be like a big, oh, okay, I must not be looking for a function. But if you forget the keyword not, then you could make that mistake. If you go through all of them, then you'll even less likely make that mistake. So on C, these are called mappings. The way you read them is you read the X to the Y. So 0, 2, 1, 3, and then I have another line coming out of 1, 4. Notice that by X value repeated, and I told you it cannot repeat. So this one here is not a function. And then if I check D, just look at your X values, 1, 2, 3. They're all different. It's a function. When I have them all labeled, it becomes very obvious which is the one I'm looking for. If you didn't notice the keyword, well, that's another issue, but the keyword should have told you you're looking for not a function, so C is my answer. All right, so on this one, you're required to read a lot. This should be pretty easy. It says that, what is the cost of the repair job? Why, if Mr. Jones did not need any parts, but the repair took X hours? So obviously you read this on your own before I went over it, and here's where our focus is going to be on. And I want to make sure I focus on the word and. When I see words like per, each, and, every, those are going to mean words for slope. Now, words for y-intercept are going to mean initial values, starting at, beginning, something like that along the words of an initial phi even. So in this case, that phi represents my y-intercept. Now, when you write an equation, this equation is obviously going to be in slope-intercept form. The slope is always going to be with the x. So that word an, that's going to be my slope. So that means the word hour is going to be my x. So when I write this, I'm going to say y equals, and your normal form is mx plus b. So if I say y equals 30, an hour, that's 30x. And then my initial phi, that's my plus b. Now, this right here is right. And then the answer is right there, real obvious. I just want you to keep in mind that I could also have said 25 plus 30x. It doesn't matter which order they're written in, but the x has to be with the 30. That's the slope. Now, I prefer the first option because that's mx plus b, but it doesn't necessarily have to be written that way. The x just has to be with the 30, so you have to find keywords for slope. Per, each, and every. All right. On this one, the keyword is what is closest to the volume of the grape jelly? I want you to notice that the picture, it's not full. It's not all the way full. I'm going to come back to that. But for right now, the word volume should hint a formula. So if we were to go to our formula chart, we'd be looking in this section. Notice that there's the volume section. That's kind of hard to draw on this one here. But I want the volume of my shape, and I'm working at a cylinder. So what's the volume of a cylinder? We'll use our adjusted formula. Pi r squared times the height. It's something that we should have already practiced. So it starts like this. We know it becomes pi r squared times the height. And in order to use it, you need to use r and h. Now, again, my focus is on the volume of the grape jelly. I'm not asking what the volume of the jar is. I don't care about how much the whole jar can hold. It's how much of it is grape jelly. So when I say radius, that should be 2. Now I want you to notice that you're pretending like there is not the rest of the jar. I can erase mine. I need you to just focus on what matters. As far as what you're seeing now in my image, you can only see the grape jelly. So the height that I'm going to use is 3. Now if you were to go and use 8, you'd be getting me the volume of the entire jar. I don't care about the whole jar. The question tells me to focus on the jelly. As far as the jelly goes, it's only 3 inches high. So plug it in. And what's pi 2 squared times 3? Now, I do want to point out some things. Like the answer choices, they're in inches cubed. That was a hint for volume, but this question flat out said, what is the volume? Let's go type in pi 2 squared times 3. So let's do, I typically type in the first part in parentheses, so pi 2 squared, and then times 3. And well, I get 37.69, which I'll round a little bit, and which is closest to that answer, G. Now, I do want to point out that it does happen where your answers could be in terms of pi. Now, when I say in terms of pi, that means you're going to work out the same problem, but without your pi. Now, in this case, this isn't helpful right now, but the answer could also be written as 12 pi. Both of those are correct. It just so happens that right now, this problem is fully worked out, 37.69. It could be that the answers are in terms of pi. And if that was the case, then I'd be looking at a 12 pi. Now, I'm willing to bet that some of those other answer choices are the volume if you use the 8 as the height. So you do need to be careful with the little tricks they throw at you, because what's going to start happening is they're going to start using answer choices that you make common mistakes on. And you take your exam feeling like you did good, but in reality, you're falling for mistakes. So you do want to look out for the wording. In this case, it was the volume of the jelly. It didn't say the volume of the entire jar. It just said the volume of the jelly. All right. This last one here, there's a bunch of ways to do this. I hope you read it and you tried it on your own first. Here are some of the ways I've been seeing people solve this today. So one supervisor for every 4 is what's supposed to happen. But right now there's 3 for every 20. So they're short some hires. Somebody I saw did it like this: supervisor, 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 supervisor. Every supervisor gets 4, every supervisor gets 4. So they just did it like this. What they figured out was that if you go and add them up, what's 4 plus 4 plus 4 plus 4 plus 4? Well, that's 20. And that means I should have 5 supervisors. So I'm supposed to have 5. I only have 3. So how many more do I need? 2. Now, some people even drew stick figures. I saw some people make a table. Make a table if that works. I mean, if you see the pattern, use the pattern. Either way, for 20 trainees, I'm supposed to have 5 supervisors for every 20 trainees. Stick figures is fine. I saw some people do this, 20 divided by 4, and they just thought, oh, well, I have 20, so every 4 gives me 5 supers. If you understand it, you use it. I would have liked this method. This is where you set up a proportion. You're supposed to recognize that this is a proportional scenario, and there's a lot of ways to set it up, but the idea is 1 super for every 4 trainees is equal to how many supers out of 20. And if you cross multiply and divide, you'd still end up with that you need 5. And if I already have 3, then you need 2 more. So the answer is C.
All right, so after reading this, the keywords that stand out here is going to be diagonal of a rectangular rug. Okay, and what I want to do, I'm going to go ahead and draw this image. So I have a rectangular rug, something like that. Then I have a diagonal from one corner to the opposite corner, and this diagonal measures 11 feet. Okay, I do want to put emphasis on feet. Okay, but the question asks which is closest to the length and the width of the rug. Now, what I'm going to do is I'm going to call length and width A and B, and I'm going to call 11 C, because I'm trying to give you guys a hint for what I'm already seeing. Okay, hopefully this will help you see it. There's a right angle, and if that doesn't help, then here's a quick trace. What you're supposed to see here is that there's a right triangle, and I have given you side C, the hypotenuse. What you're looking for, length and width, A and B, are the legs. This is a Pythagorean Theorem problem. This is where A squared plus B squared is equal to C squared. And then just a heads up, the C, often referred to the hypotenuse, diagonal is a big key word for that. So when you see the word diagonal, you might be dealing something to do with the hypotenuse, and you are here. Now, here's what I'm going to do. I'm going to check to see which one of those legs will make this statement true. By I mean legs, I mean which one of those answer choices. Now, something to watch out for. I put emphasis on feet because when you look at your answer choices, you cannot work with 2 different types of measurements. If I'm in feet, I'm in feet. If I'm in inches, I'm in inches. You can't work with feet and inches at the same time. So what I'm going to simply do is I'm going to change 8 feet and 6 inches to 8 and 6 out of 12. In turn, that's going to be read as 8.5. If I go simplify that, that's what it's going to become. So I'm going to check, does 8.5 squared plus 6.5 squared, does that equal to the diagonal 11 squared? And, well, go type it in. So you go to our calculator, and, well, actually, I already have it there. So I'm going to go ahead and use this. Notice 8.5 squared plus 6.5 squared gives you 114.5. And then 11 squared gives you 121. So 114.5. Is that equal to 121? And that would be no. So I'm going to say these legs are false. It's something that doesn't work. It's not true according to the Pythagorean theorem. So I need to keep on checking until I find something that works. So if I go check B, let's go set that one up. Remember that when it says inches, you need to do that out of 12. So instead of 7 feet 6 inches, 7 and 6 out of 12 becomes 7.5. squared. And then plus 4 feet 6 inches becomes 4.5 squared. And are these two equal to 11 squared? And well, I can already tell you it's not. If you look at the previous numbers, these two numbers weren't big enough to get to 121. The two that I'm currently working with are even smaller, so I expect that I should be even further from it. But let's go check anyways. So what's 7.5 squared? 7.5 squared plus 4.5 squared. And then I hope you guys understand where I'm getting this 0.5 from. That's equal to this, and then I already know 11 squared, but I'll type it in again. So it's 76.5. So right here I get 76.5. Is that equal to 121? And then again, that would be no, so false. So I have two more left to check. All right, so let's go ahead and I'll work it out over here. So keep in mind that 6 feet 3 inches will be 3 out of 12. 5 feet 9 inches will be 5 and 9 out of 12. And so what I'm going to do is does a squared, and then 3 over 12, by the way, if you were to go and simplify this, it becomes 0.25. So I can say 3 and 1/4, or I can just say, was it 3 and 1/4? No, it wasn't 3 and 1/4. 6 and 1/4. Or I can just say 6.25, which I like to work with decimals here, so I'll use decimals. And then plus 5 and 9/12, if I go check that, okay, hopefully 9/12 is something that we can easily simplify. But if I go check that, I get 0.75. So I'll use 5.75. It's always good to check, but there's some things you should know. So is a squared plus b squared equal to c squared? And again, I know I'm going to have the same issue. These numbers are even smaller, so I doubt I'm going to reach it, but recheck anyways. So what's 6.25 squared plus 7 point, yeah, I don't know if it was 7. What was it again? 5, my bad. So plus 5.75 squared. Don't forget the squared. And is that equal to 121? And the answer would be no. So I get 72.125, I believe. Is that equal to 121? No, so the answer is false. And then, well, all my hope is on the last one now, so let's go check the last one. And it's going to be 6.25 squared plus 9 squared. Is that equal to 11 squared? So I already know 11 squared is going to give me 121. Now let's go and find out if a squared plus b squared gives me 121. So I'm going to go with 6.25 squared plus 9 squared. If it's right, it should give me something very close or equal to 11 squared. And notice I get 120.06. And if I round that, actually, that's 120.1. I guess I'll use 120.1. Now, while it may not be perfect, it's extremely close. So I'm going to go with this, but I also want you to notice that they use the word closest, which is closest to the length. This is going to work. So the dimensions for the length and width must be D. That's the only one that comes close. So be careful with the word diagonal, which is a hint for Pythagorean Theorem. Okay. All right, moving on. Okay, so over here, we always have a lot of issues with these, and there's a bunch of structures to do this with. Let's go with the basic keyword. Right now, it's going to be true, and then the other keyword is going to be slope. Okay, this is a slope problem, but there's a topic where we want to make sure we focus that there is slopes in triangles. So every time you see a triangle, it actually does represent a slope. There's ways to represent slope in triangle with our rise over run, which is my other keyword. Right now, if we want to make this basic, we want to make sure that we know the word slope means rise over run. Now, There's a lot of reading going on this, so if you want to break it down, just go to the basic first. What is my slope? Because as far as the answer choices go, they're all different slopes. So if I can narrow down the slope, it should make it easier for me. Now, how do you find the slope? You get your perfect points. And when I say perfect, by the way, I mean any point that is on the line and the grid. Now, there's a lot of points. Just because it has a letter next to it doesn't mean that I need it, but make sure you focus on the line. I'm looking at that line slightly slanted. You can call it line segment AC, AD, DC, a lot of combinations. But here's what I do know how to start. My line is going uphill. So whatever my answer is, it's positive. All my answers are positive, so it doesn't help me eliminate. Now, when you do rise over run, it's a pretty simple thing, I hope. When you do rise over run, you just need any 2 points. Okay, I could even go as far as from here to here if I wanted to. And I know right now I'm ignoring what the answer choices are saying, but my first point is just find the slope. And let's go with that. So let's say I do rise over run with the first little triangle that I made. My rise would be 1, my run would be 1, 2, 3. So I need you all to be careful because the rise number is 1 and the run number is 3. So my slope is 1 over 3. The reason I want you to be careful is because some people put 3 over 1, which gives me 3. This is wrong. The way you find slope is not run over rise, it's rise over run. So this over here would be right, but it's normally an answer choice. So if you go check, notice that they did actually put J there. That's wrong, but you could make that mistake. Now, the right answer, which is the only remaining one with the right slope, is F. So F is going to be my answer. But I do want you to notice something. If I go use the other points, that rise would have been 2, and the run would have been 1, 2, 3, 4, 5, 6. Now, you should know that 2 over 6 simplifies to 1/3. But for those of us that are a little bit weak with your fractions and everything, or you're just plain scared, you could always just type it in to get it simplified. So if I simplify 2 over 6, then I get my 1/3. So it doesn't matter which 2 points. Any 2 will work. If you get a bigger rise over run, you simply just simplify it, and it's really the same. So we're going to go with F on this one. Okay, just be careful with all this wording. You really do want to be careful with what it's saying. In this case, if you look at AC and DC, it's actually on the same line. And if you look at G, AB is this flat line. That slope is 0. And it actually is the same slope as AE. The only issue is the slope is 0, not 1/2. And then AC and AD. Yeah, those are the same line. That would be referring to this one and this one. But the slope isn't 3 over 2. Let's see. Oh, okay, yeah, they do it. Okay, so this is what I wanted to point out. This is why we want to check the wording. There's always more than one way to get to your answer. The more ways you know, the more accurate you can be. On D, it was wrong, but notice the mistake that some of you could have made to get there. AC is this line. Is that the same as DE? Notice that we're not even talking about the same lines here. In fact, you should know that DE is undefined. That's not even a slope. It's undefined slope. So even just the statements there don't make sense. But if you had just found your rise over run, then you should so easily be able to get F. But there's other ways to prove that. All right. This last one. All right, so there's an easy way and then there's a slightly more complicated way. I'm going to go with the complicated way because that's the way you're supposed to do it when you're in 8th grade algebra. The key word is total surface area. And that word is the key word because you'll find it on your formula chart. What I also want to point out is the answer choices say feet squared. That's another hint for surface area. Now, if I go to my formula chart, we're using this adjusted one for now. We want to go ahead and focus in on surface area. So notice surface area is in, this is the part I want to focus on, units squared. But right now, what I need to focus on is the shape. If I go back, it just says it's a box. But you should know that a box is a prism. So I need to focus here. Change the color on this. I need to focus here on the prism. And this is where I get some issues. Some people don't know whether to choose the first or the second. And when you use a formula chart, you need to look at the word above it. Am I asking for lateral or total? The key word was total. I want to make sure I put emphasis on that. So when I go back to my formula chart, I'm choosing this one, the total surface area, the area of all the faces. Now, let's use that formula. And I put a little t just so that I know I'm solving for total. When you use this formula, I want you to go figure out pH and B. Now, you should know what they stand for because I've taught this, but if not, I put what the P means here. And I've taught you guys perimeter at all sides. And then the B means area of the base. All right, but here's the focus. I want to establish what my base is going to be. It's a cube, so all faces are the same, but I want to make sure I know what I'm going to stare at. I'm going to stare at those two. So when I ask you for P, perimeter at all sides, I need you to add a 1.5 plus 1.5 plus 1.5 plus 1.5. If you're dealing with a square or a rectangle or whatever quadrilateral, you better add 4 sides. Sometimes I get some weird things going out there. And then the height, that one's always pretty easy. All right, capital B. I want you to remember that it's area of the base. My base is a square. What's the area of a square? It's side times side. Or sometimes I say length times width. It's 1.5 times 1.5, which gives me 2.25. Now, hopefully we understand where I got these 3 parts. And again, I'm taking the complicated route because they're not always going to be this simple, but I'll show you the easy route at the end. Right now, what I want to go do is substitute these numbers. Okay. And you'll have to go check my numbers, but they are right. And once you sub them in, that's it. We'll need to go ahead and tap them into the calculator and get our final answer. This answer is going to be the total surface area. So let's go plug this in to our calculator. So let's see if I remember it correctly. It is 6 times 1.5 plus 2 times, I need to go back and check, 2 plus 2.25, so 2.25. And this equation should match the equation I set up. And what's my final answer? 13.5, but don't forget, get used to doing your units squared. So it ends up being C. Now, here's the easier method. If you can follow this method, what's the area of one of the squares? Well, it was 1.5 times 1.5, which is 2.25. Since it's a cube, if you know what total surface area measures, the area of all the faces, you should know that this cube has a total of 6 faces. So I really just got to do 2.25 times 6, because I have 6 of those. And if I were to go do 2.25 times 6, notice that my answer is the same. Okay, but again, use this only if you actually understand it, because this will only work on cubes. It won't work on every other shape, only on a cube. All right, so on this one, we're going to be focusing on what is the value of y when x is 21. And I want to say that to myself a few times. what is y when x is 21? I want you to think of it like this. I'm looking for 21 comma what? Now, if you look at your graph, you'll notice that you don't see 21 on the graph. This happens from time to time when we do these trend lines. Now, that's going to be fine, but that means we are going to have to focus on how to use a trend line. Okay, so we want to use the trend line, which is my other keyword, to make a prediction. Now, while the graph is limited to whatever you can see in front of you, your trend line is basically forever until, I mean, you don't need it anymore. It goes on forever and ever once I have the equation of the trend line. Now, I want to do this because a lot of people look at these wrong. When you're using the trend line, you're going to ignore everything except the trend line. I don't care about these other dots that are there. I only care whatever is on the line and the grid. So those dots that I left there, I just left them because they're not actually in the way. But your focus becomes solely on the trend line. Now, what I'm going to do is, I want an equation so that I can use it to make predictions. And there's a bunch of routes to go, so I'll show you several methods. Right now, I'm going to do this by hand. I want to find m and b because I can see that this is a non-proportional equation. And so in order to find m and b, I need my perfect points. Now, I saw several, so I'm going to use these. Notice that these points are on the line and the grid. They did not necessarily have the dots already there. I'm just going to focus on the line. So when I do m, I want to do rise over run. Make sure you check the scale, but in this case, it's a pretty easy scale. It's rise 1, run 3. And then I need to find b, the y-intercept, where the line crosses the y-axis at 0, 4. Okay, I always like to put it in 0, b form. So if I write an equation, it's going to be y equals 1/3 x plus 4. Now, this is what I'm going to use to make a prediction. I have a couple different options. Okay, and then I do want to point out, along with doing this by hand, a good backup option is to use linear regression. Okay, which I'm going to show you how to do, because some people, for what I did right now by hand, you're like, oh, that's too hard. Well, you need to go practice it because you should do it by hand. But here's how you use linear regression to get the same answer I just got. Choose 2 points, any two. I chose 0, 4 and 6, 6. And here are the steps for linear regression. So you're going to go into your stat, edit, and I'm going to plug in 0, 4. Notice that list 1 is your x values, list 2 is your y values, and then I can choose 6, 6. Now, you only need 2 points for this to work. You can use more, but you only need 2. Once you've done this, you're going to go to Stat, Calc, and then we call this linear regression method. So you're going to choose number 4. Now, some people get confused. Oh, look, there's number 8. Yes, but I want to go with 4 because it's an ax plus b. And that's going to model our mx plus b setup. We want to set up with mx plus b to show the non-proportional. All right, so 4. And then we simply just calculate. Notice, though, that my x values are on list 1 and my y values are on list 2. So calculate, and this is what you get. Now, keep in mind, the calculator does decimals, but we got 1/3. Guess what 1/3 is as a decimal? 0.333333. Now, if you remember how to do this, if you want to tell your calculator to recognize a pattern, you need to type it in at least 11 times. I'm not going to count. I'm just going to do it a lot. That looks like 11 to me. You can change a decimal to a fraction by doing alpha F1 number 4. Fraction to decimal, decimal to fraction. Ta-da, I really do have the same number. So my answer is still really 1/3 x plus 4. That's linear regression. Okay, you still have to know what you're doing, but that is a backup method if you're struggling doing this by hand. Now, from here, you can use y equals table to finish off your problem, or you can just use sub. Now, I need to prove how I got 11. How do I know it's 11? Because I don't see the 21 anywhere here. It doesn't make it there. And then just by the way, don't try to extend your graph and draw it yourself. That would be highly inaccurate. So we're not going to do that either. All right, so how are we going to do this? Well, like I said, sub and y equals table. So here's y equals table method. Go to your y equals, and you're going to type in the same equation. So we're getting 1/3 x and then plus 4. Now, what I want to do, now that I've done the y equals part, is I want to go to your table. So second table. And remember that we're looking for when x is 21, what is y? So we want to put focus on our x. And what I'm going to have to do is I'm going to have to scroll down so I find out when x is 21. So I keep on going. There's a faster way to do this, but for right now, this will get me there. This number's not too big. And when x is 21, y is 11. That's how I'm able to get to b. Now, another method that I think works just as easy is sub. 21 is an x value. Just go put 21 in place of x. So what I would do is 1/3. I'm not going to say x now. I'm actually going to put the value of x, which in this case is 21. When I go work that out, that is what y is equal to. So what's 1/3? Let's go to the home screen now. So I'll just copy this. What's 1/3? I'm not going to say x. I'm going to say 21 plus 4. And I get 11. So either way will work, but that's how we're able to get there. All right, on 2. On this case, the keyword is warmest to coldest, and this one requires more thought. First, you need to know how the temperature works, which I hope we do. But what this is going to refer to is greatest to least. When I say warm, I want you to think about the weather outside. And so we're in the South Texas, right? Or Edinburgh. We're really, really hot here. When I think it's warm or it's hot outside, I want you to think, oh, it's 110 degrees. Yeah, it's hot. It's 100 degrees outside. Now, as it gets colder, the temperature drops. For us, cold is like 60 degrees. So it's freezing. We don't want to go anywhere. It's not really that bad, but it is pretty cold. So when you get warmer, the numbers are greater. As you get colder, the numbers are smaller. So just think about you lowering the temperature at your house. If you lower your aircon, you're going to make the number smaller so it can get colder. So smaller means colder, bigger numbers mean warmer. Now, you can do this on the calculator using sort D. Sort D means greatest to least. It's sort descending. Now, I really prefer you do this by hand on just the regular number line. So I start off with 0, and then I'm just going to go put all the numbers where they live. Negative 11 would be pretty far off to the left. Negative 3 is closer to the 0. Negative 1 is even closer to the 0. And then 0 is already there. So if I'm looking at my number line like this, and I want to read them from least to greatest, it's already in order. However, I need you to be careful because I want to read my numbers from greatest to least. So if I want to say least to greatest, I start with 11 and I work that way. But I'm not asking for least to greatest. I'm asking for greatest to least. So I start with the 0 and I read that way. So which answer actually matches that? G. Now, what is sort D? Okay, so here is sort D. Let's just get whatever answer choice. They're all the same numbers anyways. And you're going to go to your, let's reset the calculator just to be safe. And when I say sort D, you're going to go to your stat edit menu. So let's see if this thing goes. All right, there you go. So stat edit. And what I'm going to do is under list 1, I'm just going to type in my numbers. So I'm just going to use these in this order just because they're there. Hopefully I can remember them as I type them in. Negative 11, negative 3, -1, I think, and 0. Now, I'm going to go back to the home screen, stats, and I want you to notice here, look at options 2 and 3. Sort A is for ascending and sort D is for descending. Since it said greatest to least, warmest to coldest, I should know to choose descending. I want to put in descending order list 1. That's where I put my data. Now, it's been done. What's been done? My numbers have been put in order from greatest to least, descending. Now, you could just type in list 1 again, and it'll spill them out here. You could just go back to stat edit, and you'll find them in that order as well. But either way, from greatest to least, I get G. Do be careful that you don't pick sort A, because then I'm sure that answer would be there also. In fact, I think that answer would have been F. That would have been least to greatest. All right. On this one, what is the solution to the inequality? I don't really want to show solver here, because this is something y'all should be able to do without. If you do use solver, it doesn't even really finish it though. That's what I do want you to be careful with. But I'll show you this. So when I say solver, and again, this is kind of like the cop-out method, so get you through 8th grade. It's not going to prepare you for Algebra 1 in high school. I want you guys to actually do this by hand, but for the sake of preparation, here's what we're looking at. All right, so let's use solver. So in order to use solver, you got to go to math. You got to scroll up, and mine says numeric solver. Yours will say solver. It's the same thing. And you need to make sure you understand how to set this up. Now, this is an equation solver. This is not an inequality solver, but it will help us a little bit, and I'll show you what I mean. Let's go ahead and write in this equation into solver. Now, keep in mind, it's not going to fully work it out. This isn't the right way, but it will help out a little bit. So let's do 1/3 x plus 10. That's on one side. And then let's scroll down to the other side. So E2 is the second side of the equation. That's going to be 3/4 x plus 5. So let's do 3/4 x plus 5. Okay, so from here, you can simply just press enter or just scroll down. And what I want us to always do is double check that equation I wrote is correct. 1/3 x plus 10 equals 3/4 x plus 5. Always do a quick double check, because so many students type it in wrong and then they find themselves, oh, they gave me this, and they trust the calculator 100%. It's only right if you type it in right. Now, by default, when the calculator's been reset, it'll automatically say x equals 0. You're supposed to press solve. Now, solve is in green, so you press alpha first, then solve. And according to this, okay, I get 12 points, a bunch of zeros, 1. I'm kind of happy this happened. The calculator has round off error. If it says 12.0000000001, you should be smart enough to understand that x is just 12. Sometimes what it'll do is it'll say 11.99999999999. You should also be smart enough to see that that is basically 12. See, actually, if I press solve here, it leaves it like that. Sometimes it has round off error. I've never really been able to figure out why, but it does that. Okay, if it's a little bit over or a little bit under, you should still see that it is 12. Okay, so using 12, all that does for me is it gets rid of these two. I still don't know the actual answer. I need to solve for it. So I'm going to go ahead and do that. So let's do 1/3 x plus 10 is greater than 3/4 x plus 5. All right, so the classes are switching. I'm going to get a class walk in, and I'm hoping they'll know that I'm working on this, but let's see how loud they are when they come in. All right, so here's what I'm going to do. I'm going to go ahead and make that line break so that I can see what's going to happen to my inequality. And the goal is to get the x by itself. Now, it doesn't matter whether you move it left or right. I personally just like it left. So I'm going to do the additive inverse plus negative 3/4 x. And when I do to one side, I do to the other. So plus negative 3/4 x. All right, so we simplify. On one side, I'm going to be left with 5. Bring down my inequality. On the other side, I can bring down my 10. And then what is 1/3 plus negative 3/4? So to make this easier on me, and so I don't have to spend a lot of extra time, I'm just going to go ahead and work that out. So what is 1/3 minus, it was 3/4? Yeah, minus 3/4. And when I do this, I end up with this. So let's assume that I'm not going to have to explain all that, how I get there. You trust the calculator. But I get negative 5/12. So negative 5/12 x. Now you got to ask yourself, which is furthest from the x? So the furthest one would be 10, so do additive inverse plus negative 10. And what I do to one side, I do to the other. All right, so then I'm going to simplify all this. This leaves me with negative 5/12x. Is greater than, and then what's 5 plus negative 10? Negative 5. All right, final step. And there's a few different approaches that different teachers use. I'm not going to worry too much about it. But what's the multiplicative inverse? So what's the opposite of multiplying by negative 5/12? The opposite would be to multiply times the reciprocal. So times negative 12/5. And what I do to one side, I do to the other. So negative 12/5. Okay. Now keep in mind, I already know I'm supposed to get 12, so it's kind of like a save-all. Now, what I've taught my students, put a little star here, is when you multiply or divide by a negative, I want to put a little star so I can remind myself that when that happens on an inequality, you have to flip the inequality. I'm going to be left with x on this side, and then what's negative 5 times negative 12/5? So what's negative 5 times... Oh, that one's not going to be the same thing, actually. It's supposed to be negative 12/5. And that leaves me with 12, which is what I was expecting, right? Positive 12. Now, this right here is my final answer, where x is less than 12. And unless you're willing to go through all the work, you wouldn't be able to tell the difference between A and C. So solver will help you eliminate, but you still have to be able to solve to get that. And I do want y'all to be careful with this part here. If you multiply or divide by a negative, that will switch the inequality.
Okay, so when you read this, the keywords that were coming out were going to be volume of a cylinder. Those words require me to go find a formula from the formula chart. So for our practice, when we go to our formula chart, we want to put focus on the volume section. Now, I do want to point out that the volume of a cylinder is originally this piece over here. However, specifically for a cylinder, what I've already done is we're going to use that part. The capital B is already going to be replaced with pi r squared. And I want you to notice that we make that connection. I circle circle and I circle cylinder because the capital B, hence over here, is going to be pi r squared. So we're going to use the original area of the base times the height, but there's an adjustment because of the circular base to become pi r squared times the height. Now, I already taught you guys to learn this one and use the pi r squared times height. Now, in order to use this formula, I need r and h. Now, h is pretty easy, 24. The issue comes with r. Now, some people luckily figure out the r just by looking at it. But the proper way is to look at the circumference. It does give you circumference, which is this, 12 pi. And then if we go look at the formula for circumference, you should find that pi d is equal to the formula, which is equal to 12 pi. And then from right here, you simply just solve for d diameter. Get rid of the pi's. So if pi is pi, then d must be 12. And if d is 12, then r is 6. So it's a little bit of thought to get there, but it should be fairly easy. And they do that from time to time to make the problem a little more difficult. So I got r is 6 and height is 24. So you simply just go and substitute. Now, type that in, and that's it. So what's pi 6 squared? Let's go to our calculator. So I like to use parentheses for this part. So what's pi 6 squared times the height of 24? And I get this as my answer. So my answer should be something along the lines of 2714.3 units cubed, or like the answer choices say, cubic units. And then which is closest to that? Well, the answer is C. I do want to add one more piece at the end. The answer came out and I'm done, but I do want us to be aware of a second answer that we're going to call in terms of pi. From time to time, your answers may be in terms of pi, which basically just means you're going to see pi in your answer choices. So when you work it out, you're going to type it in without a pi. So my other answer could be 864, and then you simply just write the pi. Okay, that is another way to say the same thing, and I always just teach both because we never know which one's going to be presented for us. All right, moving on. On this one, the key word here is compounded. Big word, okay? But that word is the key word because it's here. Very last formula on a formula chart. Now, I have these extra things here for what the formula chart actually means, but we're going to go ahead and use this. And I want you to keep in mind, you need to know what every part means. The P is the principal, but I'm using it as the starting money. R is the rate, but I want you to remember it's por ciento, okay? And then T is just the time, okay? Now, here's where I want to be careful with too, because we have different types of questions depending on what it's asking. This problem is going to solve for the total amount. Notice the previous one, sometimes interest. Depending on what it's asking for, I may have to make adjustments. But let's start with the formula that I'm using. P parentheses 1 plus R raised to the T. If I want to use the formula, I need to figure out what P, R, and T. So I told you P was starting money, and I'm starting with 7,000. Okay, R is the percent, and it's always going to be por cien, so you want to divide that by 100. So it ends up becoming 0.025. And T is the time. And if you read on, it says this is going to happen for 5 years. So I want to go and sub in what I know. Be very careful with the 0.025. A lot of people mess that up. They like to say 0.25. That's not the same thing. They put an extra zero, they forget the zero. I don't know what happens. Just be careful with the rate. Por cien. And in case it wasn't clear, this is how I got 2.5 to become 0.025. You just por cien, you divide it by 100, and that's where I'm using 0.025. Now, let's go ahead and type in that formula so we can find out what A equals to. Remember, this is going to give me the amount of the account. That's what A means. A means total amount. So let's go ahead and type in 7,000 parentheses 1 plus 0.025. Careful right here. A lot of people type this wrong. And then to the power of T, which in this case is 5. So I end up with $7,919 point, and this is to the nearest penny, 0.86 cents. Now, what I want to make sure I do is I answer the question. Now, I see the answer there. I get that. But you always want to go back and make sure you've answered the question. The question asked, what will be the value? When I ask for the value, that means the total amount. In this case, A is the total amount, so my answer is H. But I wanted to go double check because it has happened before where instead of asking what's the value, they could ask what is the interest. Now, if I ask you for interest, that changes the problem. I have the amount, I don't have the interest. It's really easy to find the interest though from a compounded formula. All you got to do is get your total amount and take away what you put in. In this case, Jonas finished off with 7,919, but he put in 7,000. So if we take away the 7,000, he really made $919, technically 0.86 cents, but that's how much his money grew by. So that would be my answer for interest. It's not asking for it in this problem, but there's often types where it'll ask for that. And I want you to make sure you get the difference for when it's asking for the value, the total amount, or maybe it's asking for the interest. How much did the account grow by? They changed the wording on it. All right. So the last one here, pretty easy question. The keywords are pretty big. It does say that this triangle was dilated. And when I taught dilated, you should know that that means to get bigger or smaller. Now, in this case, I want to remind you of how you use the scale factor. So I've taught you guys that you multiply with it. So it wants to know what is the length of the hypotenuse. So that's another big hint. This is a Pythagorean theorem problem. But notice it says, what's the hypotenuse after the dilation? After I change the size, what's the hypotenuse? So there's a lot of routes we can go. This is the route that I'm going to take. I'm going to dilate it. Right now I know that it gets bigger because my scale factor, the 3.5, is greater than 1. So whatever it is, it's going to be bigger. Now again, how do you get your scale factor? How do you use your scale factor? You multiply with it. So what I'm going to do is I'm going to multiply 3.5 times the sides. And what I'm going to end up with is 21 as my new height and 28 as my new base. And I'm going to use the dilation to find my hypotenuse. Now, when I say hypotenuse, I'm talking about the longest side. Sometimes you can refer to it as side C. The diagonal is a popular word for this. But right now, I'm looking for the hypotenuse. Now, notice I got rid of C. Now, I can see why some people would fall for it. Because if you just solve the original triangle, 6 and 8, you will end up getting 10. But notice that's before the dilation, not after the dilation. The reason I get rid of C now is because whatever my hypotenuse is, since it is the longest side, it has to be bigger than 28. So C isn't an option once I've dilated it. Now, one of the ways that I do this is I teach legs and hypotenuse. And the simple idea is that if I give you the legs, you're supposed to add. And if I give you the hypotenuse, you're supposed to subtract. I'm going to do it the shortcut way. I gave you legs, A and B, 21 and 28. So that means you got to add them, 21 squared plus 28 squared. And then don't forget the final step, which is always to square root. And if I go type that out, let's go ahead and do the square root of 21 squared plus 28 squared. And my answer should be 35. So if I go back, it's actually there. And that would be my hypotenuse, the longest side. So notice the number is bigger than 28. It makes sense. That's going to work. I do want to point out that some people type it in like this. And there's no problem with this. The issue is I don't want you to think that's the final answer. The final step has to be to do the square root. I like the first method that I typed it in, but really, so long as you know how to use your calculator, you're going to end up with the right answer. All right, so what's the keywords that are happening here? In this case, I'm going to go with this equation, n equals 1/2 q. Now, you should recognize that equation as a y equals kx equation. So, what do we know about y equals kx equations? Well, according to our formula chart, plus you should just know this. All right, sorry about that. Hopefully I got to pause it before most of the announcement went through. All right, but what you should know is that when I talk about the When I talk about y equals kx, I'm talking about my proportional equation, which you should know crosses the origin. Okay. Now, when I attempt this problem, I want to make sure I keep in mind it's proportional, and proportional on the graph anyways, because it does say on the graph, plus I have a bunch of pictures of graphs, will cross the origin. Now, I know it's a little weird, but I want to use m and b. Even though it's not an mx plus b equation, the reason I do this is because my m, my slope is 1/2, and my b, well, I don't have a b because it's a kx, but technically it's 0, 0. It crosses the origin. So what I want to go check for is the obvious. Whatever my answer is, it should cross the origin. Since it's proportional, it should have that feature. Now, if you use the pattern that you have there, the rise over run pattern, you can find out if it's going to cross the origin. And notice A. A doesn't cross. So I don't really have to focus on A anymore. Whichever answer is the right answer, it should cross the origin. So if I go check the pattern on B, notice that pattern does cross the origin. So I'm going to consider B a possibility. So if I go check the pattern on C, notice it also does cross the origin. So C is a possibility. And then on D, notice that the pattern doesn't cross the origin. So it's either between B or C. Now, M, 1/2. That represents the rise over run. So which answer has a rise of 1 and a run of 2? Just remember, when I say rise, I mean up and down, and run is side to side. So notice B has a rise 1, run 2, and C has a rise 2, run 1. So hopefully you can tell what they're trying to get you to fall for. In this case, the right answer ends up being B. Okay? Hopefully pretty easy. Just be careful with C. Some people like to switch those and they might fall for that. Okay, moving on. On this one, each equation is modeled below. So the basic is you tell me what you see. You have an equation in picture format. I want to write it out. So I see 2 x's. I write 2 x's. I see 3 tens, so I see 30. I say plus 30. On the other side, I see 2 negative x's. So I'll write negative 2x. And then I see 4, so plus 4. Now, there's several ways to solve this equation. From this scenario, I can do sub. I can do by hand. And the most popular method seems to be on the calculator with the method called solver. Now, I've used solver before. In this case, it is the easiest. I just need us to go confirm that the answer is G. So I'll try each method so I can see how each works. But here's the idea. So here's sub. Sub is going to be pretty easy. All I'm doing is I'm just going to sub the answer, and the right answer will be true. So instead of 2x plus 30, I'm going to sub the x. I'm going to do 2, and I believe it was negative 6.5, was it? So 2x plus 30. Let me go check that. Yeah, negative 6.5. And what I end up with here is 17. Okay, so that's one side. Now I'm going to go sub the other side. So instead of negative 2x plus 4, I'm going to say, and go back to the calculator, I'm going to say negative 2, and then the x will be negative 6.5, and then plus 4. Now, if the x value is correct, it'll give me the same answer. Notice it does. So what value of x makes this true? That one side is equal to the other side. Well, the answer is negative 6.5. So that's one way to get to there. Now, by hand, this is the method that we should be using. Okay, I like to do this. The goal is to get the x by themselves, so I like to move mine to the left preferably. So what's the inverse of negative 2x? Plus 2x. And what I do to one side, I do to the other. I'm going to go ahead and simplify. This leaves me with 4 on this side, and then 4x plus 30 on the other. Now you ask yourself, which is furthest from the x? And that would be the 30. So what's the additive inverse? Plus negative 30. And what I do to one side, I do to the other. I go ahead and simplify. I'm left with 4x is equal to, on this case, I'm going to have negative get get x by itself. So what's the inverse of multiplying by 4? It would be to divide by 4. And what I do to one side, I do to the other. So I'm left with x is equal to what is negative 26 divided by 4. So if I simply go check that, negative 26 divided by 4, I end up with negative 6.5. Here you go. There's the other method to solve for x. Now, the most popular method amongst my students, shame on you because you should do this by hand, is to use solver. It's probably the easiest, most friendliest. I've just been warning it. It'll get you through 8th grade. It won't prepare you for high school, so just keep that in mind. The method by hand is what you should be doing, so let's go ahead and do it now that we've proved that we can do it by hand on the calculator. So I need to go to what we call solver. So you're going to press math, scroll up, solver. And I'm going to type in the first side of my equation, which was 2x plus 30. And then scroll down so you can get to the other side of your equation, negative 2x plus 4. And I always recommend, when you get to this screen, check that the equation you typed in really is the one that you typed in. Because sometimes you type it in wrong and it's still going to give you an answer, just it's going to be the wrong answer. Make sure the last step you do is alpha enter, and notice that I get negative 6.5. Just be careful because sometimes there is round off error. I don't want that to freak you guys out. Sometimes the answer could be like negative 6.5, 0, 0, 0, 0, 0, 0, 0, 0, and then like a 1. And I don't know why it does that, but it does. But you should know that it's still just negative 6.5. So just keep that in mind. Yeah, you see, so it'll leave it there. And if I put, there you go. All right, so there's the 3 methods you can use. You should be able to use all 3, at least 2 while you're testing. All right, here we go. Last one. Which mapping does not represent a function? So let's make sure we understand what a function is. So a function is where you have x values and y values, and you should remember every x kid has only one y mom, and x cannot repeat. You kids cannot be born out of somebody else. However, your y mom, somebody else can call your mom their mom. They're called siblings. You may not like them, but oh well, you have siblings. Okay, so when you read a mapping, you just read x comma y. So I want something that's not a function. Either way, you need to go through all of them and label them. So if I check A, here's how you're reading them. 5, 1, 6, 2, 7, 3. Notice that all my x values did not repeat. So it is a function. Now, you don't have to write them out on the side. I think these are pretty easy to read. But for beginners, I might go through and label them. B is also a function. So I would read that as 2, 2, 4, 1, 6, 3. H, function, 10, 3, 12, 2, 13, 1. D, notice how you read these, 9, 0, 8, 4, 8, 6, notice what happened there, and 7, 6. This one here is not a function, but I need you to know why. It's my issues with the 8s. The x cannot repeat, and it does, so this is not a function. I do want you to notice that I don't have an issue with the 6s. Because some people, oh look, the 6 repeated. It really doesn't matter. The y values can repeat, but they don't have to repeat. So normally all I pay attention to is the x values. But I do want to point out that the 6s aren't the issue. It's the x value 8. All right, so big keyword here. Mean absolute deviation. So what is true about that? All right, so unless you actually know how to find what we call the MAD, then this is going to be a very difficult question. So to find the MAD, this is how the general setup works. You have one part that's going to represent the data. You have another part that's going to be the mean. And you have a third part that's going to be the absolute difference. So what I teach is that data is pretty much always given. And then for mean, you got to add all data and then divide by number of numbers. And then to get the absolute difference, you're going to subtract, but every answer has to be positive, hence the absolute. So when I say subtract, you're going to subtract data minus the mean. And then to finish it all off, you're going to get all your data from your absolute differences, and you're going to add the absolute differences, and then again divide by the number of numbers. And it's a pretty long process, but it is a very easy process. It just takes a while. So the good news, easy. The bad news, it takes a while. All right, but here's the idea. When I go and read this, I need to see which one actually follows the right process, which one's actually telling me the way to do it. So A says the MAD is the absolute value of the mean. And that right there would be false. Okay. The absolute value is what I use as part of it. That's not how I find the entire thing. So on B, the MAD is the average distance between each data point from the median of the data set. So it's pretty close. The average distance. Well, that is what I'm doing here for this last step. I am finding the average distance because that's what absolute value does. Absolute value is a distance. But I'm finding the average distance from data and the mean. And unless you notice it, this is data from median. The median actually has nothing to do with me finding the MAD. So while it's close, this is why we need to be good readers. This is the hard part on this. While it's close, it's still completely wrong. On C, the MAD is the average distance. So the average distance, I like that part. Each data point is from the mode. And so again, we find a technical issue. I don't care about the mode. My answer ends up being D, and then the wording is there. It's the average distance each data point is from the mean. That's what I'm going to go ahead and use. My answer is D. So long as you all get the process, that's what this is. And this, again, it's a long process here, but it's not a difficult one. Okay. All right, on number 2, we're looking for the rate of change. I want a rate of change of 6 feet for every inch. All right, so I do want to mention something because sometimes these can get complicated. Another word for rate of change is slope, which is change in y over change of x. That's the method I'm going to use here. Keep in mind, you can also use linear regression. I know it's a popular one, but I want to make sure I get this. 6 feet for every inch. Every time I give a slope, it's being given to me in change in y over change of x. What I mean is, you want to be careful that what it's asking you is the way you're going to read it. Every time it says feet, that's a y value, and every time it says inches, that's an x value. Because it always gives you slope in y over x, change in y over change of x, and rise the y value over run the x value. So before I continue, I want to make sure we understand that in all these scenarios, x is inches, y is feet. The reason is that they could have asked you in inches per feet, and that would really change the way we look at this table. The good thing is most people look at a table with the x being on the top and the y being at the bottom. But that may not always be the scenario. It is here, it just may not always be. So here's the quick version of what you're doing. You're going to do the change in y's over the change of x. So you're going to be subtracting. And I like to put the arrows so that I know where I'm subtracting. So to get the numbers I just got, I did 15 minus 12, and that's where I got 3. So to get the 9, I did 24 minus 15, and that's where I got 9. And then the same thing for the 27 minus 24, that's where I got the 3. And then I'm going to do the same thing at the bottom. And what you need to go check is what's the change in y over the change of x. So you simply just divide. Just remember, change in y over change in x. Some people say 3 over 0.5. It's not. The change in y is 0.5 over 3. This gives me 0.16 repeating, and if I change that to a fraction, that's really worth 1/6. The reason I want to be careful is because if you accidentally did change in x, which is 3 over 0.5, you might accidentally think that is the answer. But really, the right way to type it in is going to be... I actually put non-linear here for some reason. Oh, I see why I put non-linear here. There's not even a constant. If I go do 0.5 over 9, I don't actually get the same 1/6. So this isn't even linear here. But either way, if I had gotten 1/6, I need you to be careful for how you type it in. Make sure you do change in y over change of x. It's the 0.5 over 3 in this case. All right, so I'd have to go on and check the rest of these, and here are the numbers I get for g. And this one, I get the same thing, 0.16 repeating, but it's 1/6. Don't type it in wrong because then you're going to have an issue. All right, so now let's go ahead and notice the next set of numbers on h. So just to be clear, I did 3 minus 2 to get 1, 10 minus 3 to get 7, 20 minus 10 to get 10. And then same thing at the bottom. I did 18 minus 12 to get 6, 60 minus 18 to get 42, 120 minus 60 to get 60. So those are the numbers I subtracted. Notice change in y over change of x. Now, when I go divide, what's 6 divided by 1? 6. Now, you should check all of them. So what's 42 divided by 7? 6. And then what's 60 divided by 10? Again, it is 6. So this one actually already has the slope that I want, the rate of change that I'm looking for. So my answer is going to be H. I do want to point out how to use linear regression to check these. So let's say I go check answer choice H. I want to use linear regression, so the way I do that is I go to stat, edit, and I'm going to go ahead and, I don't know why I like the keypad over here, but I'm going to go ahead and type in the x values under list 1. So I'm looking at H, and my x values were 2, 3, 10, and 20. Now you technically only need 2 sets of data, so I need 2 sets of coordinates, but if you do all of them, it's not an issue. Might just take you a little bit longer to type in. So the y values are 12, 18, 60, and 120. Notice how they're corresponding. I have 2, 12, 3, 18, 10, 60. Those are the coordinates I'm talking about. Now, from here to finish off linear regression, I do stat, and this time I move over to calculate. And I want to choose option number 4. My ax plus b represents my mx plus b. And then I go ahead and click calculate. And my equation is y equals 6x plus 0. However, if this is my equation, we should know that first off, you don't have to write plus 0. And then second of all, the 6 is my slope. So by checking H through linear regression, I'm able to get that. But the work I showed there by hand is going to work good as well. All right, so next one here. So this one, pretty easy. When you write it to yourself, you should have found the keywords were volume of a cylinder. And then another hint for volume could have been cubic inches. That's another keyword. I put that on the formula chart for you guys. So if I go to the volume section, right here, notice I put units cubed. So that's one of the other words I use to show volume. So this problem could have said how many cubic inches represents the cylinder. And they don't necessarily have to use the word volume, but it still would have worked. Okay, so what's the volume of a cylinder? I go to my formula chart, I'm looking for volume, I'm looking at cylinder, and I use this formula primarily. There's going to be an issue, but I want us to see it. Okay, so the formula starts off like this, but since I'm working with a cylinder, I go ahead and I use my adjusted piece, but I want you to notice that they gave me area of the base. The reason I want to focus on that because my original formula is volume equals area of the base times the height. So when I go work this, I don't have to actually go do pi r squared. I already know the area of the base. It's 78.5. It says it there. And then my height is simply just 8, and that's all I got to do. So what's 78.5 times 8? Well, I'm going to go ahead and check that. 78.5. Oh, typed that in wrong. 78.5 and then times 8. And that ends up leaving me with 628. And my answer comes out there nice and easy. So in this case, just be careful with that area of the base. The better your formulas, the easier it'll be to see that little detail. All right, big topic going on here. Parallel lines cut by a transversal. So this image you're looking at, a lot of things happen with this. There's so much vocabulary I can pull out of here. But for right now, I'm going to go ahead and focus on the main keyword, corresponding angles. The way I define this word is same spot, but different location. Now, an easier way to visualize this is I want you to pretend that what you're staring at is two streets cut by a railroad track. So let's pretend that I draw a car, and it's just a regular car. And there we go. And so I have this car here that makes that one a street. I have, let's go ahead and make another car over here. So there's another car. And then it's being cut by a transversal. And I'm going to go ahead and pretend that this is going to be a train. So let's go ahead and draw a train. Let's see, something like this, I guess. All right, there's my little train. All right, now it's a weird scenario. I guess I should have thought about this a little bit more. But what's happening here is I want you to pretend that you and your friend are standing in the middle of the intersection. Let's pretend that none of these vehicles are moving. So you're perfectly safe, but just in case, don't go stand in any intersections. But what I want you to think of as same spot, different location is you and your friend standing at these intersections. If you and your friend both look up, both of you would be looking towards angle 2 and angle 4. So one of my corresponding angles could be angles 2 and angles 4. Now, there's a total of 4 pairs that I can look at. So if I'm thinking you and your friend are standing at the intersection looking up, you're both looking at the same spots in a different location, such as 2 and 4. But I could also say, what if you and your friend both decide to look to the left? Then you and your friend would both be looking at angles 1 and angle 3. So you'd both be looking at the same spot, different location. So 1 and 3 are another pair of corresponding angles. And then I could look down and I could say that angles 5 corresponds with angle 7. And I could also look to the right and say that angle 6 corresponds with angle 8. So think of you and your friend standing in the center, staring at the same spot, but in a different location. Now, when I go through these answer choices, I'm just going to focus at the beginning of this. 1 and 3, they are corresponding. They're in the same spot, different location. So A is actually going to be true. 1 and 2. So let's go ahead and focus on what these other ones are. This is good vocabulary practice. So let's look at 1 and 2. I already probably have my answer, but 1 and 2, I want you to notice that they lie on a straight line. They are linear angle pairs, is kind of a fancy way to say it, but we know that as supplementary. So they actually, those are supplementary angles. They are definitely not corresponding. So C says angles 1 and 4. I mean, there's not any rule for what they are, but they're definitely not corresponding. So that's also false. And then D says 1 and 6. So 1 and 6. So if I've talked about angle 1 here and angle 6 over here, they are vertical angles. They're actually equal to each other, but they're not corresponding. So my answer is still going to be with A. So corresponding angles are going to be same spot, different location. So imagine you and your friend standing in the middle of an intersection. That's very safe in fiction. Don't go do that in real life. All right. Question 2. So I want to put emphasis on the trend line. Using the trend line. Okay. I'll come back to that word. But using the trend line, a team member practiced 12 hours a week. So I want to make sure we understand 12 hours a week. That is my practice hours. The reason I'm putting emphasis on that is because I'm looking for number of free throws. When you read a trend line, we need to start putting more emphasis on the titles. And I'll admit, I don't always pay attention to the titles, but when it comes to these problems, you need to, because you need to understand what they are giving you. I'm saying 12 practice hours. That is an X value. And I'm looking for the number of free throws. That's a Y value. Now, this problem turns out to be really nice and easy. Okay, because I have 12 practice hours. I have the X value of 12 in my graph. So I really just got to pay attention to, here's where X is 12 and my Y value is somewhere right there-ish. It looks like it could be, it looks like it's 7, so I'm not too confused about that. But here's what I want to put some practice with. The issue is that sometimes, and it didn't happen in this case, but I want to show you as if it had, sometimes this could happen. And notice that's very possible for those dots to be there. The reason that I have an issue is because if those dots had been there, some people might think, oh, look, when X is 12, the Y value is 6 because there's a dot there. What I want to make sure we understand is that when we are looking at a trend line, we are only looking at a trend line. In fact, when you do a trend line, you're supposed to ignore everything except the line. So if I blotch out these dots, they're actually not important. I only care about the line. So as best I can kind of get rid of them. That way your focus is only on the line. So based on that line, when X is 12, what is my Y value? Okay, and then that's where I get 7. But if there's extra dots in there, you need to be careful that you use only the trend line. Okay, and then it didn't happen here. Just be careful for when these problems don't give you all the graph, where they don't show you the X value that you're looking for. When that happens, it didn't happen here. You have a nice, pretty graph here, so you're fine. But when that happens, you're going to have to use the equation of the trend line to make predictions. So that would be another level of this problem. But for right now, make sure we know how to focus on just the trend line. All right, and then this one here, I know some of you are really discouraged from the reading part, but this is a weakness. We need to work on it. I do want to make sure we understand what this symbol here means before I start, though. This symbol is going to represent, here's the trick I use to remember. If you draw it, it kind of makes like an L. And then your other one, this kind of makes a G for greater. So that's one of the tricks I use to remember that. Hopefully it helps. All right, so a lot of reading here. We got to set up a lot of inequalities. That's what we're going to call these. And let's start with the first one. So A says the area of a rectangle with dimensions 30 and x units. So just keep in mind, area is length times width. So if I want to set up the first part, I need to do length times width. So what's 30 times x? 30x. And then it says is 60 square units more. So it's added to it because it's more. More than. Is 60 square units more than a rectangle with dimensions of 45 units and x? I need to take another look at that right here. So is 60 units more than? Normally the words more than means switch, but I'm pretty sure in this case they're using it like this. More than, and then 45x, and then either way I have my issue. I'm looking for a less than, not a more than or a greater than. I'm looking for a less than here. So A would be false. All right, moving on to the next one. So a $60 fee plus 30 an hour. In this case, I want to remind you that the words for per, each, and every, those are keywords for slope. So this hour is my x value. Now I could say 60 plus 30x, but I do want you to keep in mind it's the same as if I had said 30x plus 60. In this case, it's irrelevant, but both of these would actually be the same. Some people argue about what's the right way. In this case, it really doesn't matter. But I'm going to go ahead and set it up like this because that's the order it says it in this case. And then it says Jeff's repair shop charges 45 an hour. So this other guy is 45x. Now, pay attention here. Fast car, so that's the first one I wrote, charges less than Jeff's. So the first equation, oops, don't want to do that, is less than 45x. This one actually does match what I'm looking for. So more than likely it's going to be B, but we always want to go through and finish all of them. All right, so C, it says 60 increased by a number times 30. This is where I struggle because I know they should be, I wonder if it's worded right. 60 increased by a number times 30. 60 increased by a number times 30. If I'm reading it right, 60 increased by a number and then times 30. And then you're going to have to forgive me because I'm a little bit uncertain if it could also mean this version, though the wording isn't clear enough. 60 increased by a number times 30. Is it 60 increased by a multiplication, or is it 60 then the increase then multiplication? All right, I need to go probably touch up on these. I'm going to go ahead and stick with this version of it just because I know it mimics the answer I'm trying to get. And then it says is less than the number increased by 45. So this would mean x plus 45. So I know it's still false because of this back portion, but I do want to be careful with the front over there. Probably going to have to go touch up on that a little bit. So the last one, D, says 60 plus 30 a lesson. So that one's going to be a little bit easier. 60 plus 30x. And then another club charges 45 a lesson. So we need to focus on, will the first club be more than? So I'm going to use greater than the second club. And that answer is also false. So the answer I'm going with here is B. A lot of reading, a little bit tricky, and I know it's intimidating, but the more you practice these, the better you'll get. I'm going to probably have to go practice these too, but not too bad. You'll get through them. All right, so big key word here. What is the orientation? Okay, of this figure after it is translated 2 up, 5 down. All right, so when it comes to transformations, you definitely need to know what the word orientation is. So the way I describe this word is I say, I use it in a sentence and I tell my students, all of you use your calculator with the same orientation. And pretty much that's going to help most students understand. And so here's what I mean. Let me go ahead and open up my camera. And let's see. There we go. All right, so here's I can actually have it off. Here's just your regular calculator. And if I ask you, what's the position it's facing when you use it, you all should say it's like this. Everybody uses it like this. This is the way your face is looking at it. So if I ask you, if I tell you the way it's facing, then I would say the orientation is like this for all of us. So the orientation is going to represent the position it is facing. So when I come back here, the question is, what is the position it is facing when I translate it? Now notice I circled the SL. That's a little trick to remember that translate means slide. 2 up, 5 down. Now keep in mind, if I slide this up or down or side to side, anywhere that I slide this, notice the position it's facing. It doesn't actually change. It's still facing the same position always. So the ones you want to be careful with is, let's go through the 4 transformations. So the first one is translation, a slide. No matter where you slide, side to side, up or down, this is having the same orientation. The position it's facing stays the same. So if I go answer this, actually, after I slide it, it should be facing the same way. So if this is my original here, and after I slide it, it's still facing the same way, then I should get B. Now back to this. There's 4 transformations. There's slide, which notice it does keep the orientation the same. There is reflection. So reflection is a word for flip. Now notice if I flip it, if I keep on flipping it, this right here is not the same orientation as this over here. So reflection does not keep the same orientation. All right, now another one is going to be rotation. Now notice that rotation, a turn, does not keep it the same orientation. Okay, so when you rotate, it does not keep it the same orientation. All right, and then the last one is going to be dilation. So if I simply just zoom in on this, notice that it is facing the same position. And if I zoom out, notice make it smaller, make it bigger, then it is still facing the same position. So the only ones that affect the orientation are going to be reflections and rotations. And then the ones that don't affect it are going to be dilations and translations. All right, moving on. So in this case, which statement best describes the data? I would say the hint is more in the answer choices. I see a table and I see equations, and I want to find one that fits. There's a lot of methods here. I personally think sub is going to be the easiest. Substitution method works so easy. It's really easy. Some people really like linear regression, and I'm fine with that method. And then, of course, y equals table. It's not as popular as I think it should be, but I mean, all of these work fine. I'm going to go ahead and show all of them either way. I'm going to start off with sub real quick, just to show you how easy it is. So the answer ends up being H. That slipped out, but that's fine. Let's go ahead and prove H real quick. So I'm going to get the X values, and I'm simply just going to sub them into X. So if I'm checking answer choice X, what's 3 times, notice I'm not going to say X, I'm going to say 1. So what's 3 times 1? 3. Plus 1 is 4. And that actually is what I'm supposed to get. And I would just keep on doing that all the way down. So if I check 2, what's 3 times 2? 6 plus 1, 7. And bam, that's what I'm supposed to get. So I just keep on going through. It's helpful to check all of them, by the way. You should check all the points when you are using sub, because sometimes they work for the first, but they may not work for the last. And so you check all of them to be safe. So if I check the 3, rather do that in red. But if I check the 3, what's 3 times 3? 9 plus 1 is 10, so checks out. And if I do the 4, what's 3 times 4? That's going to be 12 plus 1 is 13. So it looks like through substitution, H is the answer. Now, let's go ahead and try y equals table method. Okay, this one I think should be used more. It's not used as often as I would like, but here's how it works. Let's go ahead and put this. Okay, so what we're going to do is y equals, and I'm going to input all of my answer choices. So the first equation is y equals x plus 3. Next is 2x plus 3. And then 3x plus 1, that's the answer I know is going to work, but we're checking this method anyways. And then 5x minus 1. And this is called y equals table because I've done the y equals part. Now I want to go to table. So I'm going to press second table, and I'm looking at all my answers here. What I want to put focus on is the x value. So notice how I'm moving through the x value. I want to go check the values I know. When x is 1, y should be 4. So notice answer choice F could still be in, G is out, and then H is still in, and J is still in. But now I need to go check when x is 2. So when x is 2, y should be 7. So notice F is out, and then notice y of 2, it was already out, so it doesn't even matter. And then y of 4, that's J, it's also out. There's only one point so far that already has 1, 4 and 2, 7. That's going to be y of 3. And if I check the other ones, notice 3, 10 is in there and 4, 13 is in there as well. So I think this method's pretty easy. You're checking all of them at once. All right, and then we got the final method, linear regression. I think it's overused, but it works, so I mean, use it. It'll get you through 8th grade. It just won't prepare you for high school. Here's linear regression. Let's go back to the home screen, and we're going to go to Stat, Edit, and I'm going to use, I didn't clear it the last time I used it. I'm going to use the list 1 for x values and list 2 for y values. So I'm going to do 1, 2, 3, 4. Those are my x's. And then my y values will be 4, 7, 10, 13. Okay. And then from here, you're simply going to go to Stat, Calculate, and then option number 4. Remember that ax plus b represents mx plus b. And then I simply just calculate. So this is going to tell me my answer. You just have to rewrite it. So a goes in place, 3 goes in place of a, 1 goes in place of b. So I'm just going to write 3x plus 1. And that would be it. And that would still come out to be h. So all 3 methods are fine. I think my preference would be sub, because that's a more, you're using your brain right. Y equals table is good too. And then linear regression, it's probably the simplest. I think sub would be better for you guys. All right, last one. So 500 liters is equivalent to 500,000 milliliters. And then I want to focus on milliliters, but in scientific notation. So, basics. Scientific notation is always some number that has to be between 1 and 10. Then it's always times 10 to some exponent. But that exponent, okay, if it's a positive exponent, then your answer must be greater than 1. But if it's a negative exponent, then the number has to be less than 1. So basically, I taught you guys that if you're working with a big number, it's greater than 1 positive, and if you're working with a small number, then it's less than 1 negative. And then right here, I'm working with 500,000. I would say the number 500,000 is a big number. So whatever my answer is, it has to be positive. Now, aside from me noting that this answer is off, another one that's more obvious is D. I said my answer has to be between 1 and 10. that part of the answer we call the significant digits. It's not between 1 and 10. So it's between A and B, and I prefer to do this by hand, although there is a way to do it on the calculator. But here's the method by hand. You put where your decimal is understood to be, and then you move it to where it's supposed to stop. I'm just going to put the decimal there. I know that 5.0 is between 1 and 10. That's how I know to stop there. To get my actual exponent, I just count how many times I move the decimal. 1, 2, 3, 4, 5. So my exponent should be to the power of 5. So when I build the whole thing, it's 5.0, because that's my significant digit. That's my number between 1 and 10. Then it's times 10 to my exponent. In this case, I know it's a positive exponent, and I know it's 5 because that's how many times I move my decimal. So my answer is A. It's a pretty easy problem. You should know how to do this by hand. Here's the calculator for those of you that you're way too dependent on the calculator. So let me go and clear this. The calculator has a scientific mode. I want you to pay attention to the top part. I don't know if you guys, I can't actually point at it. So, oh look, it is kind of showing something there. Maybe that'll come on the video. In the top part right here says normal. What you want to do is you want to go to mode, and notice where it's blinking right now. It's on the normal. I want to change it to sci. That's going to be scientific. And basically what that does is anything I write in, so like let's say I do this number, it's simply just going to rewrite it for me in scientific notation mode. Now, this mode is E is the exponent. So my answer would be 4.501 times 10 and then to the 6th power. Right now, I want to type in 500,000. So make sure you get the zeros right, because if you mess that up, then everything else is wrong. There's 500,000. Notice it's 5 e to the 5, because that means 5 times 10 to the 5th, which is still going to be my answer. Just make sure that when you're done with scientific mode, and it'll say here on top that it's in scientific mode, make sure that you go back and change it to normal. If you forget though, all those fails, just reset your calculator. Second plus 7, 1, 2. And then that'll take care of it. And on the top of my calculator will say normal again. All right. Yep, that was the last one there. Okay, so let's go ahead and move on. All right, so keywords here. You probably want to read this several times, but this is what I'm going to focus on. My main keyword is going to be the same. This word tells me that something is equal to something else. So I'm going to need to write an equation. The second part I'm going to focus on, the other keyword, is how much will one notebook cost? Every time I see the word notebook, that's what I'm trying to solve for. So for this sake, notebook means X. So when I read the problem and it says they sell 2 notebooks, notice that notebook is going to be X. So I really have 2X plus, that's pretty easy, a $30 backpack. That is equal to, so notice I have the first side of my equation. 2X plus a $30 backpack is equal to, it's the same price as 12, and then notice again, notebooks. That means X. So 2X plus 30 is equal to 12X. Now, there's 3 ways that I use to solve it. In this case, sub is an option, solver is an option, and then the method by hand is another. I'm going to go ahead and do solver and by hand on this one. So let's start it by hand first. Okay, so the goal is to get X by itself. In this case, it makes more sense to move all the X's to the right. So what's the inverse of 2X? Plus negative 2X. And what I do to one side, I do to the other. And then I simplify all this. And left with 30 is equal to 10X. Next, X isn't by itself. So what's the only thing in the way? It's a 10. So what's the inverse of multiplying by 10? Dividing by 10. And what I do to one side, I do to the other. this leaves me with x is equal to, what's 30 divided by 10? 3. So doing it by hand is pretty easy. This one wasn't too bad. There's nothing tricky here. But every notebook must cost $3. Now, it does help to go check the solution. I would strongly recommend that. So instead of putting x, I'm going to put my solution. So I want to put that x is 3 to go check this. So is it true that when the notebook costs $3, that 2 notebooks, that's 6 plus 30, is 36 equal to 12 times 3, which is also 36? Yes, so my answer really is going to be B. Okay, I would recommend you check it like that. Notice that method is basically sub. And then the last method is solver. So again, when you do solver, you go to math, scroll up, solver, and I'm going to type in my equation, which was 2x plus 30, and then that equals to 12x. And then just be careful because there is round off error from time to time, but most of the time it comes out good. In this case, there you go, I solved for x. Just always go and double check that you wrote your equation right. So x is equal to 3. All right, moving on. So we want to focus on the top part here. I want to know what's true about the image, but I want to focus on reflected across the y-axis. This is one of the 4 transformations. There's a lot of things going on. I think the best way to do this is to actually show the reflection. Now, you should know the properties of reflections. And they mention a whole lot of interesting things on the answer choices, but for right now, let's just do the basic. Let's go ahead and reflect it across the y-axis. It's an easy thing to do. We're just going to literally count. And here's how we go ahead and flip this across the y. You just simply count how far away it is. So notice that A is 3 away from the y-axis. So on the other side, it must be 3 away from the y-axis. So that's my A, and then I label it prime. So I'll do the same thing for the others. Notice B is 1 away from the y-axis, so it's 1 away on the other side. And then C is, what is that? Is that 6? So it's 6 on the other side as well. And then that is C prime. So there you go. And then I like to shade it so I can show that it's a new one, but even if you don't, it's still pretty easy to tell. Now, let's see what they're talking about. What is true? So F says the image will have the same orientation. And what does that word orientation mean? It means position it is facing. So tell me, are they facing the same position? And notice after the reflection, no, they're not. So F is going to be false. And I always go through all of them because remember, I'm looking for true. G says that the image will be the same size. And, well, if you look at it, it actually does look the same size, but I want to put more emphasis on there's only one rule that will change the size of a shape, and that's dilations. And I'm not doing a dilation here, so if I say it's going to be the same size, then that's actually true, because a reflection does not change the size. A reflection does change the orientation, though. All right, so I'll take a brief pause for the announcement, but all right, going on. H says that the image will have the same shape, and, oh no, it will not have the same shape, my bad. Not have the same shape. So that's pretty weird. I mean, I guess it's the equivalent of this. I don't know if this makes any sense. When I flip a calculator, it suddenly becomes a phone. It just changes what it is completely. Yeah, that doesn't work. And then when I flip the phone back, it simply just becomes back to a calculator. Yeah, that's not going to work. So definitely a big false on that one. And then J is the image is located entirely in quadrant 1. All right, so let's pretend that we don't know where the quadrants are. You all really should, but let's pretend we don't. If you look at your dilated image, you can tell it's not even on one quadrant alone. It's on several. And then just as a refresh, here are your quadrants. Okay, they go counterclockwise, by the way, but my bigger concern is be careful with B. If I remember correctly, B prime is technically on quadrant 2 and 3. So, but A prime and C prime, those are entirely in quadrant 1. All right, and then the last one, here we go. So, when you write this, there's a lot going on, but I want to go ahead and put emphasis on the main keyword, which is going to be simple interest. So I want to find the simple interest, and just be careful with these problems. You want to make sure that you answer the question. Okay, I'll come back to it. Okay, so right now, if you go to your formula chart, let's go ahead and open that up. So if you go to our formula chart, right here at the bottom, we have two interest formulas. I'm going to focus on simple because the keyword was simple. So we're going to use I equals PRT, and notice how we should already know what PR and T stand for. So when I go and write this formula in, I equals P, R, T, I want to go and figure out what P, R, and T are going to be. So when I say P, I mean the starting amount. So it says they started depositing 1,000 each year on her birthday. And it's actually an interesting one. Yeah, okay, so 1,000 each year. So the starting amount is 1,000. I'm pretty sure this is supposed to be solved another way, but the way they worded it ends up just working out fine.
Oh, yeah.
So let's do the R. The rate is going to be the por ciento. So your percent, it has to be done por cien because we cannot leave a percent as is. We need to change it to a decimal. So this becomes 0.035. And I want you to be careful with this. If you can't do that in your head, simply just go type it in. 3. Well, I'm not doing it on the right screen. 3.5 por cien. Divide it by 100, and that's where I get my 0.035. And then T is time. Okay. In this case, I'm going to use 5. Okay, this is going to happen for 5 years. Now, I know the problem says that they deposit 1,000 each year, and then the interest earned is removed from the account. So how much interest will the account earn after year 5? So if I'm doing this correctly, on year 5, actually, they've been putting in 1,000 every year. So there should actually be $5,000 in that account if I'm doing this right. So hopefully y'all see why I changed that. It does start off with 1,000, but I'm only checking after year 5. So I actually changed my time from a total of 5 years to only that year. I said the wording on this is kind of weird. It is a little bit, it's not very clear. But I'm going to go ahead and use this, and it should work out just fine. What we're going to do is go ahead and plug in the principal, which is, in this case, 5,000. Sorry about that change. The rate, which is 0.035. And then a time. And notice I changed it to 1 because that amount of money will only be there for that 5th year, which is only a total of 1 year with that amount of money. So what's 5,000 times 0.035? And then times 1, which I don't really have to do, but I'll do it just because I already set it up. So with that much money in there, on the 5th year, it makes $175. Now, that is what I is equal to, my interest. And in this case, the question asks, how much interest? How much interest will the account earn? So am I actually done? Did I answer the question? Yes, I did. I know how much interest the account earns after year 5. It earned $175. All right, simple question, not too many words, and it simply just asks, which of the 4 real numbers is the largest? All right, so before I start, here are the answers we're supposed to get. Okay, What I want to do though is, do we know how to get these answers? Okay. Notice I put dot 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 because they're irrational. So I'm not going to keep on putting forever decimals. I'm just going to go up until the nearest tenth in this case. Now, the reason I want to put emphasis on this is because let's look at the square root of 130 minus 5. A lot of students that struggle with the calculator, they type it in like this. Square root of 130, and then they put minus 5. And I'm hoping some of you can see why that's wrong. Notice that I ended up actually getting 6.4, but here I'm showing 11.18. The reason is that when you type in a square root, you need to tell it to stop. Notice the difference that happened there. Look where my blinker is at. Now, my problem is square root of 130, stop, and then minus 5. This is how I'm getting 6.4. Some people make the mistake of not typing it in correctly, and you want to make sure you tell the square root to stop when it's supposed to stop. So if I check the next one, it's 3 square root of 14. Stop it, and then plus 6. So I get 17.2. And then 16.23 is already as a decimal, and then here is the last one. We want to do 7 pi. Okay, and now if you were to use 3.14, it probably would be fine, but since I have the pi symbol, I'm going to use the pi symbol. 7 pi over 2, and I get 10.99. I guess I could use 11, but it doesn't really matter. As far as which one is the greatest, which is the largest number, that one should easily fall for answer choice B. Okay. Now, if it helps, you can use a number line, and you can put them all there in order from least to greatest. But I really think it would just be easier to see this number. These numbers aren't hard to see, but the one that would fall furthest out would definitely be 17.2. So my greatest number is 3 square root of 14 plus 6. All right, so next one. David rides his bicycle at 8 miles per hour. So which graph represents this relationship? So I'm hoping we know that 8 miles per hour is the slope. I'm looking for a slope of 8. So another way to find slope is rise over run. Okay, so which one has the right rise over run that I'm looking for? Now, before I continue, something that I do want to point out, and you're supposed to check for this always, is before you count rise over run, is always check the scales. A lot of people forget what they're counting by, and it's the scales aren't always going by ones. In this case, looks like for all of these graphs, the y scale, or in this case the m scale, is going by 4s. So every time we rise 1, it really means 4. So just something to look out for. Now, as far as getting slope, it's important that you understand that you need to find perfect points. And those points have to be on the line and the grid. So I chose the origin in 8, 4. So my rise, although it looks like 1, is really rise 4, run 8, which becomes 1/2. That is not the slope I'm looking for, so I keep on looking. All right, so on the next one, I found the origin, and I'm going to go ahead and use 2, 16. Now, mind you, there's other points I could have used that work, but so long as you get 2 perfect points, it's going to be fine. My rise in this case, it looks like 4, but it's really 16, and then my run is 2. That one simplifies to 8 anyways. So this is more than likely going to be my answer, but I want to check the rest just to be safe. J is easy. That's 0 fun, so it's not J. Slope dude reference. And then we're looking at H. This one, this is just the slope of, it looks like 1 over 1, but it's not. It's rise 4 over 1, which is 4. So this one here, I thought it was pretty easy to find. Just by the way, if any of you had used these 2 points, that would have worked too. The rise there would have been, I know it looks like 2, but it's rise 8, because it's 4, 8, and then run 1, which is still going to give me 8. Okay. Either way, these are the same answer, but one had to be simplified, one didn't. It's still going to be G. All right, last one. So in this case, you're looking for the key word. You got several, actually. The most obvious is going to be volume. I also want to put emphasis on cubic feet, and then conical. So volume is always the easy word to find, but you can't do volume unless you know what shape you're doing volume for. And then I also just want to point out, look at your answer choices. Those are also a hint for this is going to be a volume problem. Now, the word conical is kind of confusing to some students. It's just fancy for cone. In fact, it says when a truck dumps dirt, and, well, it kind of looks like a little mountain. And, well, a mountain looks like a cone. So, in this case, I want to find the volume of a conical pile. So, let's make sure we know where to go choose our formula on the formula chart. And we're going to be using the volume section. But in this case, it's volume of a cone. So I'll be using this formula here. This is the adjusted version. So we want to go ahead and use that. That's how it starts, but because of the circular base, it's going to be pi r squared times the height. And all I need to use that formula is r and h. So just be careful with the r. It is 6, not 12. It is 6. And then the height is going to be 8. So just plug it in. What's 1/3 pi 6 squared times the height of 8? And there shouldn't be anything else to it. If you go ahead and type that in, let's go ahead and do that. Let's do 1/3 pi 6 squared and then times 8. And I end up with 301. So I'm looking for an answer really close to 301, and that answer does come out. I'm going to go with B. And then I just want to point out that there is also an answer in terms of pi. So how do I get 96 pi? It's the same problem. You just simply type it in without the pi. So if I just copy that and I delete it, that's where I get 96, and I just bring on the pi next to it. It doesn't help you on this problem. It's just from time to time, your answers could be asked in terms of pi. All right, so this one, we need to read and read carefully. It says, Joe takes out an easy access loan for $500. It costs her $10 for every 100 and a one-time fee of $200. How much did it cost Joe to get the loan for $500? So, okay, there's a lot going on here. 10 for every 100. So I'll remind you that per, each, and every, these are keywords for the slope. So this means that the $100 is my x. And then a one-time fee of 200. So keywords like one time, first time, initial value, those are going to be words for the b, the y-intercept. So this is going to be my 0, comma b. And then, well, how much would it cost? Well, here's how we find the cost. The cost is 10 per every 100, which is 10x, and a one-time fee of 200, so plus 200. So what we got to do is, if we want to find the cost, we got to figure out x. So x is every 100. So if you borrow 500, that's how many hundreds? That's 5 hundreds. Hopefully that makes sense. Okay, so for every $100 bill they hand you, they're going to charge you $10. So that's 10 times 5, and then plus 200 is 250. So my answer is A. That's how much it costs. Now I want to be very clear. This is just a side note. Somebody paid $250 to borrow 500. They still owe the 500. This is it, they paid $250 to borrow 500. Just that's what happened. Okay, so not only did Jill pay $250, she also got very ripped off. Hopefully, when you're an adult, you don't make decisions like that. All right, but moving on. Which best represents the distance between 2 points. So this topic, I want to know how far is it from A to B. And then here's what happens, and I hate this, don't do this. Some people try to go count how far it is. That is really, really wrong. All right. Now, you cannot count diagonally, by the way. However, you can count up and down and side to side. Because in this version, I do have the grid lines to help me count. So 1, 2, 3, 4, 5, 6, 7. And then same thing over here. 1, 2, 3, 4, 5, 6, 7. All right, now some of you are like, well, what is counting 7 down, 7 to the side gonna help? Well, I'm hoping that you'll see it at this point. The diagonal, that AB, it makes a right triangle. And the 7 represent the legs, A and B. And if I give you the legs, you should know that you can find C, the hypotenuse, which in this case is the distance from A to B. So what are you going to do with 7? You're going to add them. And I don't mean just 7 plus 7. I mean 7 squared plus 7 squared. And then the final step is to take the square root. Okay. This is a Pythagorean theorem problem. The issue is that you need to see it. And please, please do not try to count diagonally. I don't know what people do to try to do that. It doesn't make any sense, but it happens every time. And sometimes you might be lucky enough to get close enough, but it's still a very wrong method. So let's go ahead and work this out the right way. 7 squared plus 7 squared is this. That's not my final answer. And then the final step is square root. This is my final answer. So I get about 9.9, which is really close to 10. So there you have it. Okay. Please do not pick J. Some people think, oh, look, 7 plus 7 is 14. J says the square root of 14. You're telling me that the distance from A to B is about 3.7 if you were to go with that logic, and that doesn't make any sense. A and B are much further apart than 3.7. And then F is wrong for so many reasons. And so then we have G. I don't know, maybe you can get G or H if you were to count it by just looking at it. You could fall for G. But H is the correct answer using the Pythagorean theorem. All right, moving on to the last one. This is a pretty tricky question here, but we're going to focus on the rate of change. And then if that didn't help, look at the answer choices. They say inches per hour. So that's another hint for rate of change. Now, I'm going to go ahead and use the change in y over the change in x. Now, we need to establish what is the y values, what are the x values. And then the answer choices kind of tell us. The answer choices are always in y over x, because the slopes that they're giving me, the rates of change, are always change in y over change of x. So when it talks about inches, those are going to be my y values. And when it talks about the hours, those are my x values. So what I want to do is I'm going to go ahead and write them in x comma y form. Notice that at 1:30, that's one of my times, comma, the pole is at 20 inches. So it gave me an x comma y. X is time, y is inches. And then it says at 3 p.m., that's an x, it's at 27.5 inches. So I know the water level is rising, so that might be helpful, except all the answer choices say that it's rising. So let's go ahead and move on. Let's set up a change in y over change of x. So let's establish a first set of values and a second set of values. And according to this, I'm going to do 27.5 minus 20. The bottom is where it gets tricky. I'm going to do 3 minus 1:30 o'clock. Okay, I'm not just working with regular numbers. I'm working with time numbers. I'm going to want to be delicate about that. The top part's pretty easy. What's 27.5 minus 20? And I get 7.5. It's the bottom that I need to be delicate with. How does 3 minus 130 equal 1.5? Some people are like, what? What'd you do? What'd you do to get that? And, well, that's where I want you to pay attention. So 1.5 is 1.5. Okay, fine. But I still don't see where we got that. Now, one thing you can do is we can put our focus on this part of the problem. There's something going on here. What you need to look at it as, maybe just the way you say it could make sense. What's 3 hours minus an hour and 30 minutes? So if I have 3 hours, and here's a really elementary way to do this. If I have 3 hours, and then I have an hour, and notice an hour and 30 minutes that I'm going to take away. So I could take away this one with this one, and then I guess I can take away half of one. So this one gets taken away. I'm left with an hour and a half. A more proper method, hopefully this makes sense, is when you subtract time, you don't borrow the way you normally would. Like 3 minus 0 is 0, fine. But notice, how do I do 3 take away from 0? It doesn't work, right? So what you got to do is you're going to borrow an hour. So that becomes 2 hours. But when you borrow an hour and I jump over this point here, what I'm doing is I'm passing over 60 minutes. So these just become 60. Now what's 60 minutes minus 30? I get 30 minutes. And then what's 2 minus 1? I get 1. So I get an hour and 30 minutes, which in turn I can change to 1.5. An hour and 30 minutes is an hour and a half, which I can say is 1.5. And what I want to finish it off with is simplify. What's 7.5 divided by 1.5? And I get 5. Of course, I want to go check that, right? So what's 7.5 divided by 1.5? And that's how I get my 5. So my answer is 5 inches per hour. I'm going to go with A. And you have to excuse the mess I just made there. Okay. Okay, so we need to write an equation. And at a glance, when you see your answer choices, they all kind of look the same. So we do want to be careful about this. And we'll start off basic. Let's go ahead and read the main part we need to focus on. A salesman earns $300 a week plus 20% of his sales. And I want to be careful because we're not sure if the X value is 20 a week or 20% of sales. So we do need to finish reading. The question goes on to say, which equation can be used to determine his salary S if his weekly sales is X dollars? So even the weekly sales, is it a week or is it sales? And hopefully, though, the wording makes sense for us to put emphasis on sales. So everywhere it says the word sales, the sales is X. So my X value should be connected to the 20%. So one way to write this would be that Y equals 300 plus 20%, 20% of his sales, X. And then what I'm going to do to finish it off is simplify. I can simplify 20 out of 100 to 1/5 X. And, well, you should be able to find your answer. It's going to be A. If you want to rewrite it as 1/5 X plus 300, that's fine. The idea here is that 1/5, that 20%, has to be with the X. Okay? So you don't want to put the X with the wrong spot. My answer ends up being A. Okay? All right. Keep in mind, both of those answers are the same. It's just two different styles. I prefer the bottom style, 1/5 x plus 300, just because that's more mx plus b style. But technically, I could say y equals 300 plus 1/5 x. All right. The next one here has a lot going on. I'm going to do something before I'm going to come back to it. But let's start with this. The key word is simple interest. And so I want you to find me the simple interest. And, well, that keyword is on your formula chart. So we go to our formula chart. And it's all marked up. Let's go ahead and clear it up. And we're going to focus on the simple interest part over here. So I'm going to use this formula, and then notice what P, R, and T stand for. So I'm going to start off with I equals PRT, and we're going to go figure out what P, R, and T are going to be. Okay, so P is the starting amount, and it starts off with $1,000, and R is the rate, which is going to be por ciento, and T is the time. It's going to be 10 years. So if you look at the answer choices, it's going for setup. Okay, I put emphasis on something in the problem, value for investment, but I'm going to come back to it. Right now, I'm going to go ahead and do my setup. My setup is 1,000 for P, 0.025 for R, and T is 10. Now, I'm really tempted to pick an answer of J. Notice J matches it perfectly. However, this question is asking for the value of her investment. You see, when you use these formulas, you want to keep in mind what I is solving for and what A is solving for. I is solving for the interest and A is solving for the total amount. You see, right here, if I go work that out, not even have to, but if I do, I get 250. And that is the interest. So if I asked you how much interest, then I'd be done. My answer would be J. However, J is telling me how much interest. And the issue is, I'm not asking how much interest. I'm asking what the value of the investment is. So I have this answer of 250, great, but that's not what I'm asking for. So then, how do I finish it? So, how do you find the total amount? Well, if I'm made 250 and I have 1,000, then I simply just gotta add them. And so if Nia put in 1,000 and she made 250, then she has a total of 1,250. So which answer will give me that? Which one does the interest? Notice which one does this part over here plus what she put in. And that answer ends up being G. So you want to make sure you go back and answer these. I'm always trying to put a special emphasis on these questions because you need to find out if you're asking for interest or the amount. In this case, it actually wants the value of her investment. That is going to mean the amount. So the way I find the amount is you got to add both. Keep in mind, if I had used the other equation, this other one here, it would have already given me the amount. And I don't know if anybody caught it, but, oh no, not exactly. Yeah, this part here, trying to throw it in there, but that's still wrong. And then notice that H doesn't even use the time frame in there, so this one's wrong. But I can see a lot of people falling for J, so I do want you guys to watch out for that. Okay, on to the last one. These can be tricky. They're not hard, they're just very tricky. I would recommend graph paper when you do this. Maybe even the patty paper helps out. But here's one of the styles to answer these. Your keyword is going to be translated 3 down, and then a separate keyword is rotated 90 clockwise. So here's what I want us to know. There is rules for transformations. A translation rule is going to look something like this. When you translate 3 units down, you're supposed to remember that there's X and Y values. And when I move down, that is going to be a decrease, but to the Y value. So nothing's going to happen to the X, but the Y value will be decreased by 3. Okay. Second, my other keyword tells me that it's going to be rotated 90 clockwise. So there's rules for that one too. When you rotate 90 clockwise, you have to switch your coordinates. And then I like to make a clockwise arrow to show that the x will become opposite. So what I got to do is two rules, one after the other. So let's see if this makes sense. I'm going to go ahead and I'm going to do this with the first point. So the first thing I'm going to do is I'm going to get my original -4, 3. And what I'm going to do to the rule is, let me go ahead and copy this. I'm going to go ahead and do this rule to it. So what I'm going to do is I'm going to keep the x value, and I kind of want this to be more aligned. All right, there you go. So what I'm going to do is I'm going to keep the x value. So my x value is going to be -4, and I'm going to get the y value and decrease it by 3. So what's the y value decreased by 3? So this answer becomes -4, 0. Now I'm not done, because I'm doing one transformation and then the other. So this is my answer is if I had only translated it, but I wasn't finished. So what I got to do now is, let me go ahead and copy my other rule. I got to go ahead and apply this rule, my 90 clockwise rotation rule, to this point. So I need to go ahead and switch them. So instead of -4, 0, I'm going to say 0, -4. And then I'm going to make my clockwise arrow to show that the -4 will become opposite. So it's really 0, +4. This is my first answer. So what I can do with that is I can already get rid of D and B. But then I still got to go and finish it. So notice it took some work, and it's kind of a skill that you got to practice with these rules. You don't want to just do this just cold. You want to make sure you understand how these rules work. So hopefully what I showed you made sense. Let me go ahead and move this down a little bit. You guys can see that better. And I'm gonna go ahead and do that for the next point. So let's go ahead and try that for the next point. So my next point would be 6, 9. So I'm going to go ahead and I'm going to keep my x value, 6, but my y value, the 9, will decrease by 3. So let's separate that a little. So this is going to give me 6, 6. Now I'm not done. Now I got to rotate it 90 degrees clockwise. So that rule says that I will switch them. So you can't really tell that I switched them, but I did. And then my clockwise arrow will make the 6 opposite. So my other answer should be 6, -6. And that simply just leaves me with one more answer choice left. It is going to be C. All right, now, I still don't get this, sir. That was really hard. Like, I don't. All right, here is the idea on how to do this. Let me see if I can pull up a certain image that I'm going to need. I hope, wait. This should hopefully be enough. Yeah, that didn't work like I wanted. Let me go ahead and erase this then. So the other route to take is, like I said in the beginning, use graph paper. So what you would do is you would just do each one at a time. This is probably the safest bet to use. So you go plot your original coordinates. The issue is I don't have all my coordinates. This doesn't fit in there. But let's just do one. I'll give you the idea. So I'd go plot -4, 3, somewhere here, 6, 9. That doesn't have space. All right, 2, -3. Somewhere here. And let's just pretend that the other point was somewhere here. So I have this triangle. Just imagine you had more bigger size grid paper. And what you would do is you would just do the actual transformation. So when it says translated 3 down, I would just go move everything 3 down. This is a lot easier to do, by the way, on graph paper. And you are provided with graph paper when you test. So here would be my answer after the translation. Notice though that it's not an accurate picture because my top point over here wasn't actually there. But it's a more or less the idea. And then from here I would rotate it. Now, I have the ability to do this. Let's see if it makes sense. No, I don't think it's going to show exact though. I'm going to do this. Just, I don't know if you can imagine doing this with actual grid paper, but what I'm going to do is, this is going to be total craziness here. I rotated the image. This is probably better with the graph paper. You can do this on a graph though. Okay, on a paper you could actually manipulate, and then once you actually do all the steps, you could see all the answer in detail. Okay, I should probably try to get me some grid paper. Let me go try to find some actually. This is worth doing. Showing you by hand here. Okay, let's give this a better shot. All right, so oops. Try to go over this in finer detail. Hopefully this will make sense. So what we want to put focus on is how do you do this without the rules? Because a lot of students struggle doing this with the rules. So there's got to be a method to do this by hand, and here's how this is going to work. So what we want to do is we want to go ahead and graph our original points. So here's -4, +3. Okay, we have 6, 9. So 6, 9. And then we have 2, -3. All right, so this makes me a triangle. Go ahead and be neat about this. And what I want to do to this triangle, according to the problem, is I wanted to translate it 3 down. Now, if you can use the rules, better for you. That's the right way to do this. But if we just do it on paper, this is what it's going to look like. Every single point gets moved 3 down. So 3 down, and then 3 down. Now, this is not my final answer. Okay, this is just my translation of 3 units down. So hopefully y'all can tell that it's just a slide down. Now, the other transformation was to rotate it 90 clockwise. So for this one, I like to use a patty paper. I think it's an easy method. But there's also a turn your paper method. I like that one too. Some people aren't very good with it, but the patty paper seems to work for most. So here's how we do the patty paper. Now keep in mind, I want to work with the one that I've translated. So what I'm going to do is I'm going to copy the one that's been translated, this one here. Okay, and then I'm going to go ahead and trace that triangle as well. So by the way, patty paper is just wax paper. The ones that you put in between hamburger patties. And then I want to make sure that I trace the axis. That way I know when to stop. So this is what I have. I've simply just traced my triangle. Looks like I'm missing. It's not drawing at all. This is probably better to do with pencil since the lead can write on wax paper easier. All right, but here's what I'm doing. From here, go ahead and line up the origins. As what I want to do is I want to put my pen on the origin, and I want to rotate my paper. Now, the reason I copy the X and Y axis, that I made that little plus sign, is because it's going to tell me how far I've gone. So notice this would be 90. Notice I'm going clockwise also. So if I go here and I go this way, this is 90 counterclockwise. That's not going to work. I want to go 90 clockwise. So from here, I'm just simply going to move this 90 degrees clockwise, and there you go. I stop. So one of my answers is going to be right here, and that's at 0, 4. So I'm going to go mark 0, 4. Okay, line it back up. My other answer is going to be at, looks like -6, -2 over here. And then my final spot is at, wait, looks like I copied this a little bit wrong. Let's see. Oh no, there it is. It's going to be at 5. No. Did I move this? Oh, I moved this really bad. Nope, this is what I get for not tracing it very good. The last one, it looks a little bit off here. I guess I didn't trace it super good. But it should be at 6, -6. So I'll go ahead and mark 6, -6. And this here would be my new triangle that has now been rotated 90 degrees clockwise. So it's kind of a mess of a paper. I mean, there's a lot going on here. Let me go ahead and shade my... It's probably better if I use some type of program, but no, this is going to work. So my final answers would be -6, -2, 0, 4, and 6, -6. So if I take this work back to my original problem, it does come out. My answer would still end up being C, if you can follow all that. This is a topic that we want to study before we go into our big exam, our STAAR exam. There's a lot of rules on translations, reflections, rotations, dilations, and for some of these, it's simply just easier to understand once we actually draw it out. So I do recommend that you go in and you practice this stuff by hand. And was that question 3? Yeah, okay. So let's go ahead and move on. So which statement is true about the two graphed equations? Except they're not actually graphed. You have to graph them. So I want to go ahead and do this work by hand. This is something that we haven't practiced in a while. But let's go ahead and graph those two equations. And then just to keep a heads up, what do we call two or more linear equations? We call it a system of equations. And then what's the solution of a system? It's the intersection. So we want to go ahead and try to figure out the intersection that's going to happen here. But that requires us to graph it. So let's go and graph the first one by graphing M and B. So I'm going to start with the B, which is 0, 3, and then the slope is 1/2. Now when you graph by hand, you always start with B, the y-intercept. I like to put it as 0, 3 because that's an actual coordinate. And then from here, I'm just very nice and slow, very carefully, I'm going to rise 1, run 2. And that's my new spot. And I'm going to keep on doing this until I run out of space, but this is the method we're using. You start with the y-intercept, 0, B, and then you show the rise over run 1/2. Now, a big heads up here, this slope is positive. It should be going uphill like I'm showing you now. Okay, if the slope had said negative, my rise over 1 would be showing a downhill slope. All right, so there's my first line. Now, let's go ahead and move on to the second equation. My B and my M. So my B is 0, -3, and my M is, careful here, you all should know what's understood to be in front of that negative x. There's an understood 1, so it's -1, but I'm going to put it as a fraction so I can represent a rise over run. So let's go ahead and start with that one, 0, -3. So it starts down here. Now, keep in mind this slope is negative. It needs to go downhill. So when I show a rise over run, it's going to be going in a direction that's downhill. The rise 1, run 1. I don't like to say left, right, because you can technically go in both directions. And notice what happens right here, the magic spot. Okay, there is my intersection. It's at -4, 1. Okay, I do want you to be careful because if you read it wrong, you might accidentally fall for D, 1, 4, -4. That would be such a shame to do all this work only to mess up at the end. Now, I do want to go over how to do this on the calculator, because it's a very easy process. It's just a lot of steps, but it's not bad. So let's go ahead and let's go to our calculator. Let me go ahead and this way. Here we go. And let's reset it just to be safe. And so how do we do this on the calculator? Well, the first thing we want to do is we want to graph it, because that's what we did. So let's go to our y equals, and let's go ahead and put both equations. So the first one being 1/2 x plus 3. And then my second equation being negative x. Make sure you put negative and not minus x. So negative x and then minus 3. And I want to go ahead and graph this. So pretty awesome, the calculator graphs it. And I can kind of see the intersection. I mean, I'm pretty close to seeing it, but I'm not 100%. So some of the things, there's a way to do it, but let me go ahead and show you this before. One of the things I like to do is I like to change the format, and I like to turn on the grid line. Okay, go ahead and press enter on that. I want you to notice that when I graph it, there's grid line on the back, which actually makes it a lot easier on the eyes. I can kind of see a little bit better now that it's actually at -4, comma positive 1. But we can do actually one step better than that. Let's go ahead and press second trace. Let's go to calculate. So we want to calculate things on the graph, and notice number 5. As long as you understand that you're looking for the intersection, the word intersect should stand out. And in this case, all you got to do once you've done intersect, you got to press enter 1, 2, 3 times. And it'll say there for me the intersection is at -4, comma 1. So this is how you do it on the calculator. I think it's pretty easy, but it's something you want to review. All right, moving on. In this case, I have a sphere, and I am asking you for the volume of it. So what's the volume of the sphere? So this is definitely going to require a formula, because the word volume is a big word on your formula chart. So let's go ahead and scroll to the volume section. And in this case, volume of a sphere. We're going to go ahead and use this formula here. I want to be careful with this. I have so many people that say squared. It is 4/3 pi r cubed. Make sure you check your formula chart. A lot of people just do without. It's not going to work. All right, so let's go ahead and use the formula 4/3 pi r cubed. All right, now, in order for me to use this formula, I need a radius. So what is my radius? And what they do is they give me circumference. So what I got to go do is I got to go solve for radius. And here's the quick version of it. The circumference is pi d, which is equal to 20 pi. Pi means pi, so d means 20. And if I solve for it, I end up with diameter is 20. So if my diameter is 20, then my radius is 10. Now, let's go ahead and solve that. So what's 4/3 times pi times 10 to the third? So if we use our calculator, I'm going to go ahead and type in 4/3 pi and then 10 to the third. All right, so we'll check this out. You see, it's weird because I don't see my answer there, but there is something that I missed. I'm hoping you guys will catch it. In the answer choices, they're all in terms of pi. So I've been waiting for this to happen, and it happened now. And what a lot of people will do is they'll work it out. The thing is, the answer you got here, 4188, it's not wrong. It's just not in terms of pi. So how do I get the answer in terms of pi? Well, the proper method is you simply just type in the same problem, but you type it in without the pi. So let's just do the same thing without the pi, and this is what comes out. It's actually pretty neat because that's exactly what I'm looking at here. So the answer in terms of pi is 4,000/3 pi. I have to just write the pi symbol next to it. Now, my answer here isn't wrong. This is right. And if you wanted to, what you simply could do is just go work out all the answer choices. So like if I do 15 pi, so I check A, so what's 15 pi? Notice this is what it would have given me. And then I can go check G. Well, notice I'm trying to get 4,188. So if I go check G, what's 144 pi? It's not close to my 4,000, so no. Let's try the next one. So 972 pi. And then this ends up giving me closer, but still not close enough. And then if I check J, notice that 4,000 over 3, and then pi. This ends up giving me, notice it's the answer that I originally got. So if you go through the whole trouble of working out all your answer choices, you can still get there. It might take a little bit longer, but so long as you know how to manipulate your answers, you're fine. I would recommend you just know how to get your answers in terms of pi. Okay. All right, looking at this last one. So the college information, right? I do want to make sure you guys read it carefully. There is some stuff here that if you didn't read it right the first time, it's going to be really easy to overlook. I'm looking for the cost for 4 years. Okay, but the part I didn't want you to overlook was that the information it's showing you is the cost for a year. So if I add it all up together, this is what I end up getting. This is the cost of a year of college, or university in this case. It wants me to tell you the cost for 4 years. So times 4. So what's 23,800 times 4? And you get 95,200. My answer is C. There is a lot of things I could do to this problem to make it more complicated. It doesn't do it here, but I do want to point out, if it asked how much it was going to cost, but let's say Brandon received scholarships, or Brandon received grants, this would actually take away from the total cost, because grants and scholarships would be money for college. Okay, so they can throw stuff in there like that. So a lot of the keywords to look out for here are, well, tuition and fees, room and board, books. Other can sometimes be replaced with transportation. Okay, so those are the 4 costs to look for when you go to college. But then some of the questions are going to talk about the 4 ways to help pay. So just to mention them really quick, the 4 ways to help pay are going to be student loans, grants, scholarships, and work study. So those are ways to help you pay for college. Okay, there's just one of them's kind of a trick. Student loans, it helps you pay, but then you have to pay it back. So it's not really like it's not free money, but it is money to go to school. So the idea of the vocabulary is there. All right, so on this one, we need to write an inequality. And there is one part of this we want to be very careful with. So the word is more than. Okay, so what does the word is more than mean? Well, that should signify an inequality, and then we just need to make sure we get the difference. So notice the little tricks I'm doing with my inequalities. That is how I write the difference. So on this one, I'm going to start off with my inequality. Is more than. So I'm going to use my greater than symbol. So on one side, I'm going to do 3 times a number, the sum of 3 times a number and 25. So I'm going to be adding, so when I broke down the words, I'm going to be adding, it's a little bit big. I'm going to be adding 3 times x and then 25. On the other side, is more than, so greater than, the number increased by 7. So the same number, x, increased by 7. So that'll mean x plus 7. Notice I can already get rid of one of my answer choices. It had my less than symbol, but the rest are good. So we need to figure out which is the right one. And from what I wrote, the only one that matches now is going to be B. So we do want to be careful when we're reading these. This one didn't seem too tricky. If they ask me to solve it, hopefully y'all can solve an inequality. Just remember that when you multiply or divide by a negative, your inequality must switch. All right, on the next one, Billy's moped shop. So on this one, I want to focus on these. When are the total charges the same at both shops? See, that word right there tells me that I need to write an equation. And then there's two sides. So I'm going to set one side as Billy's, and then I'm going to set the other side as J for Julio. So when do they both charge the same? So for what number of hours? If anything, if I put emphasis on hours, hours is what I'm trying to solve for. So hours is my X value. So everywhere you see hours, because that's what I'm solving for, that's your X. So when it starts off saying Billy's moped shop charges 17 an hour, this 17 an hour is my X. So I would say Billy's is 17X. Now when I go read to Julio's charges 9 an hour. So notice hour is my X. And then plus 16 for the helmet, because it says and. So and is another word for plus in math anyways. So that one's going to be 9x plus 16. And I want to know when they're same, so that's why I set them equal. So I got three options. You got solver, you got sub, and you can even do it by hand. So I'm going to go ahead and do it by hand just as a start. So let's go ahead and get the x's together. So I like to move all my x's to one side, preferably to the left. So that's what I'm going to do here. So what's the inverse of 9x? It's going to be plus the opposite, negative 9x. And when I do the other side, I do what I do to one side, I do to the other side. And I'm going to be left with 16 is equal to 17 minus 9. That's going to be 8x. And then I got the x on the left side, and now I need to get the x by itself. So how do I get rid of my 8? So what's the inverse of multiplying by 8? That'll be dividing by 8. And what I do to one side, I do to the other. And this will leave me with x is equal to 2. Okay, so that's another route we can go with. You could do solver, you could do sub as well. Let me go ahead and show you solver because it's a popular method. All right, so for solver, we want to go to our calculator and head to math, scroll up, and then solver. And then I want to go ahead and type in each side of my equation. So one side is 17x, while the other side is 9x plus 16. And then always do a quick double check that the equation I'm seeing here actually matches what I'm trying to solve for. Now by default, x will say equal to 0, but we know we're supposed to press alpha, enter. And then just keep in mind, sometimes there is round off error. So if your answer comes out to be 1.9999999, you should know that's basically 2. And if it comes out to be 2.000000001, then the same thing, you should know that it is 2. Okay. So in this case, the number of hours for them to charge the same is going to be 2. All right, moving on. All right, so on this one, that is one crazy looking shape. Keyword, I want to focus on this. There are 3 right triangles. That's a big hint. Right triangle is a hint for Pythagorean Theorem. And then the actual question asks for the closest length of RS. So I'm looking from here to here, and then if I trace that in, I want to make sure I put focus on what I'm actually looking for. Okay, so how do I find RS? Well, I want to use the Pythagorean theorem, but you'll notice that this side that I'm looking for right now is the hypotenuse, and I would require the legs. And when I look at the legs, I'm missing a leg here, and I'm missing a leg here. So how do I figure out those two sides? Well, one of them looks pretty straight easy. Well, actually, several of them do. What you're going to have to do here is
3 right triangles, you're actually looking at 3 Pythagorean theorems. And see, this blue right triangle, I can actually use to solve. And in this case, that 26 is the C. And if I give you the hypotenuse of that one, then you'd have to subtract. So what's 26 squared minus the leg, which is in this case is going to be 5. And I'm going to get minus 5 squared. And then don't forget the final step is to square root them. So let's go type that in. So what is, let's get out of here. So what is, let's do the square root first. What is 26 squared minus 5 squared? And so one of my missing sides is going to be about 25, and let's just round it to the nearest tenth. So about 25.5. So this part in here would be 25.5. Now, I do want you to notice that I'm looking for RS, not the leg where I'm currently at. The reason I mention that is because if you pay attention to your answer choices, A isn't the answer I really want. And then technically, if that's the leg of the red triangle, the hypotenuse that I'm looking for needs to be bigger than 25.5. In fact, it has to be, yeah, so I can actually get rid of B. All right, and then we have to go and find the next one. So the next one I want to focus on is, let's use, what color would work? Would yellow work? Let's try yellow. So I got this third triangle here at the bottom, and I got the same dilemma. I need to go and find this side here at the bottom over here, but in order for me to do that, I would need to find that leg. So in this case, that's a leg because 13 represents my hypotenuse. So what do we do to find that one? Well, we'd have to subtract 13 squared minus 5 squared. And then don't forget your final step is to square root them. And this one comes out to be 12. It's one of those 5, 12, 13. If you can't tell, then go ahead and type it in. So we would do the square root of 13 squared minus 5 squared, and that actually gives me 12. So I now have my legs so that I can go back and focus on my red triangle. So the original triangle that I was focusing on, I can now actually focus on it because I now know the 2 legs. So what would I do to find the hypotenuse? What do you do when I give you the legs A and B? So you're going to have to add them. So my third Pythagorean theorem is going to be to do 25.5 squared plus 12 squared. And then don't forget to do the square root of that. So let's go ahead and work that out. So what's the square root of 25.5 squared plus 12 squared? And I'm looking for an answer really close to 28 to the nearest tenth, 28.2. So approximately 28.2. And if I check my answers, well, the only 2 that are left, it's close enough. So a triple Pythagorean theorem problem. I would say this is a higher level Pythagorean. We do want to be careful, but notice it wasn't too bad. If you can visualize what I'm focusing on in the picture, you should be okay. Okay, so after reading this, you should have found that there's a lot going on, and it looks pretty easy at a glance. But I want to just emphasize, at a glance, there is something that makes this a little bit harder than the norm. So what we focus on is the trend line, and I want to know how much money after 15 months. Now notice how much money, the amount of money. That is going to represent my Y value, and 15 months is going to represent my X value. So what I'm looking for here is when X is 15, what is my Y? So I'm looking for 15 comma blank. Now what some people try to do
is they extend their line, but I want to do this first because when I talk about a trend line, I want to make sure I put focus on the trend line. I do not care about the dots that are near it anymore. Now my focus goes directly only to the line. There's a couple there that I left because I can't really get rid of them, and they're on the line, so those points are actually fine. But my focus is when x is 15, and notice I try to extend my line, and again, this isn't very accurate, but when I try to do this, what is my y value? Now, the only thing I can tell you is 500 seems too high, so I can get rid of b. The issue is that 400 might be possible, 425 might be possible, maybe pushing it, but 475 is also possible. So notice this way isn't going to be accurate enough because any of those points could be it. So what do I do? Well, let's pretend that we didn't have that part of the graph. You should still be able to find out when x is 15 what is the value of y. And they do this sometimes. They don't show you enough graph to fit it. So let's pretend I was to block off. What I would do is I'd want to get 2 points. So I chose the origin, and it looks like 7, 200. Now it doesn't matter exactly which 2 points. They just have to be perfect points on the line and the grid. I thought these two were fine, so I'm going to use these two. Now what I want to do with them is I want to go ahead and do a linear regression. You see, I may be limited to what I see on the graph visually, but algebraically I can get my equation, and that equation goes on forever. So let's go make an equation that works forever using the origin and 7, 200. So how do we use linear regression? Stat, edit, and I'm going to type in 0, notice, 0, and then my other point was 7, 200, so 200. And then your steps are as follows. You'll press stat, calc, and then I want to do linear regression method. Make sure you choose number 4. And then you simply just calculate. So the equation that I'm going to get is about 28 point something. Notice it's a little bit off, and the reason it's a little bit off is because the points I chose may not have been exactly perfect. I can only be so accurate based on how the line is drawn. If we're lucky, we get a nice pretty point. If not, then we don't get a nice pretty point, and oh well, I should still get really close to the answer. So I'm going to use the equation y equals 28.6 x. Now, let's use that equation. From this point, I have several options. You can use y equals table. I like that method. You can use sub as well. And then for whichever two you want to use, it doesn't really matter to me. But let's say I use sub. All I'm simply going to do is, in place of the x, I'm going to sub what I know my x value is. My x value is 15. So what's 28.6 times 15? And that's one way to solve for the y. So what's 28.6? And then, whoops, I didn't type in the 2. So what's 28.6? And then parentheses, not x, but my x value. And that should equal to my y. So one of my answers is 429. That's using that method, which is pretty close there to C, 425. So I would probably be safe enough to go with C. And then that would be it. So it looks like it would be pretty close to 429. So let's go ahead and use y equals table. So we're going to go with 28.6 x. And then when I go to the table, you're going to want to make sure you scroll till you see where x is 15. So I can keep on going. And then when x is 15, the y value is 429. So again, it's still really close to C. So these require a lot more work than at a glance. Although I'm sure that some of you might have been able to guess that, oh, it looks like 425. And sure, you might have gotten close enough. Just, it's not a very accurate way. All this work I did is probably more accurate. It's better to be safe. All right.
Number 2, easy keywords here, least to greatest. And according to what I've taught you, that should mean sort A. So that I do believe I have on the formula chart there at the very top. So when I say least to greatest, this is what I'm referring to when I say sort A. So there is a method on the calculator which we can use. I'll show you how to use that. But really, it's a pretty easy answer. You should know which one is the greatest. I got rid of F and G for some reason. Not sure why. Looks like 3.56. Something to do with that? I'm not sure. Let me go ahead and show you what I'm doing on the calculator because my work here didn't make sense. Let's see, although which one should be the least? 3.550 is the least. Least to greatest. Oh, okay, I see. It looks like here 3 2/5 is 3.4. That should actually be the least. So the same issue happened over here. And then let's see. 3 2/3 is 3.6 repeating, which is actually greater than 3.56. But if you're not good at seeing your fractions, then you're going to want to go ahead and use the sort A method. So it's pretty easy. So what we're going to do is we're going to go to our calculator. Again, you have to make sure you understand that sort A means least to greatest. So I like to think of an airplane. When the airplane is ascending, it's starting from the ground and then working its way up to the sky. So it's going from least to greatest. All right, but we go to our calculator. And let's go ahead and reset so we can... And what we want to do is we want to go to stat. Now, notice here on the stat menu, that at numbers 2 and 3, it says sort A and sort D. So ascending, descending. Now, I know I'm going to use sort A, but before I do that, I need to make sure I have my data in. So let's just pick whichever answer choice. It doesn't matter. I'm going to pick F, even though I know it's not F. The point is that I just need to have my numbers in there. So we got 3.5. Let's do 3 2/3. So let's type in a fraction. So 3 2/3. And then I got 3.56. And 3 2/5. Yeah, so I'm working on this during school, during spring break. Those bells, I guess, are still going off. Okay, and so now that I got my data in, I'm going to go back to stat. And I know that I want least to greatest, so ascending order. Now, here back at the home screen, you just need to put in the list of data. I put mine under list 1, so I click enter and it's been done. So what's been done? If you just type in list 1 again, you should see them in a different order this time. Now, notice that it changed some of my fractions the way I wrote them. So your best bet is just to go back to stat edit, and you should see them here in the right order. And so which answer choice matches this order? This order that are in least to greatest. And then that's how I ended up getting H. Now this should be something you can do without it, but it is there for those of you that struggle with putting numbers in order. All right, third one here. So keyword is, what is the lateral surface area? All right, so lateral surface area and then prism. Let's go to the formula chart because I've seen those words there. And then I also want to point out that the answer choices also kind of hint what's going to happen here. This is an area problem, a surface area problem. So let's go to our formula chart and we're going to go look at surface area. So right here. Now, the way I break down the section that I'm going to be looking at is I go to the first keyword, and then I go to my next keyword, And then you have to look at your third keyword. Was I focusing on lateral or was I focusing on total? And in this problem, the keyword was lateral surface area. So the way I choose the last piece is based off of that word. So I'm going to be using S equals PH. Notice P means perimeter at all sides of the base. And then H should just mean height, which we should know. So we go back here. I like to do a little L so that I know that I'm doing lateral. And then I need us to find P and H of a prism. Now, I'm not even going to draw the shape. I'm not going to put too much focus because you're given everything you need. Notice when I ask you for P, the perimeter of the base, notice it already says what it is. The perimeter of the base is 28. And then what's the height? It also just says it. There's no need for me to draw the image if I'm already given the information. All you really got to do is sub it in. So what's 28 times 6? Normally I have to do a lot more work to find my information, but in this case, the way this problem is structured, it gives you everything. So you just have to know what every part of the equation stands for. So what's 28 times 6? So what's 28 times 6? And I'm looking at 168. So my answer should be 168, and then this will be inches squared since I'm dealing with area. And the answer comes out there. So this is one of the easier ones, I think, if you know how your equation works. All right, so after reading this, we're looking for which equation best describes a relationship. So, easy thing to notice first is, as far as an equation goes, you know it's a linear equation, and then you should know it's a proportional linear equation. So, since it's proportional, it crosses the origin, which you can clearly see there, and then that means my equation has to be a y equals kx. So, all I really need to find my equation here is k. And k is the constant, which is another word for slope, which is a rise over run. So all I really need is a rise over run. So it's an easy thing to do. The only thing I do want to be careful with is the scale. A lot of times we overlook the scale. We want to pay attention to it because it's not always going to go by ones. In this case, one of the scales is going by fours. So that's going to affect the way we count. So what's my rise? Well, my rise, according to what I'm seeing here, is 12. Now I know it looks like 1, 2, 3, but you have to count by fours. So it's actually 12. And my run is 4. Notice this one, 1, 2, 3, 4. This one looks like 4, but it is 4 because of the scale. And so then you just simplify. What's 12 over 4? It becomes 3. So I'm looking for y equals 3x. Now, if you're weak at this, you could have used linear regression. I don't think it's necessary here. It was much easier to do rise over run, but I'm just going to mention it there as an option. So we'll put in a little thought cloud. Okay, as a backup, you could always use linear regression. Now, on this next one, I actually am going to use linear regression. I'm going to take my time doing this one, but I want to know which student had beans that sprouted proportionally. So the first thing I want to mention is I'm looking for something with a 0, 0, and then it has to have a y equals kx. So some of the details about being proportional. It'll cross the origin and it'll have a y equals kx equation. So the first thing I'm going to do is I'm going to go ahead and I'm going to break down this table because this is a really complicated table. It scares a lot of students. What you can simply just do is write 4 individual tables. So let's say I'm going to use linear regression. Well, it would help if you saw the tables. So notice the one adjustment I made is at the start. At the start, everybody was at 0. So when x is 0, everybody's y values were also at 0. So I'm going to make the same tables, except all my y values are different. So for the first table,
I'm going to go ahead and make y's of 1 Mary's data. So 0, 3, 6, 9. For the second table, y's of 2, I'm going to make that Leon's. And then the same thing for third table and the fourth table. Now, what I'm going to do is I'm going to do a linear regression on each of these. So it's going to be a lot of linear regressions, but as long as it takes, I know I'll be able to get a right answer. Now, there is another approach that I would recommend. I'm going to throw this in here at the bottom. You could just solve for k, y over x. That's probably the better approach, but let me show you how linear regression could help here. So we want to go ahead and go to stat, edit, stat, why is it putting x? Oh, because I'm putting x, my bad. Stat, edit. And then let's get that data out of the way. And let's go ahead and put in the first set of data. So it's all the x's will be 0, 3, 6, 9. And then let's go ahead and do the first y's of 1 data. So Mary's is 0, 3, 6, 9. She actually has the same exact data. Wait, my 0 didn't click in. 0, 3. Now, by the way, linear regression doesn't work unless you type in your data right. So stat, calc, number 4. And then this is the equation I'm going to get. I end up getting y equals 1x because it's the same data. But here's what I want to mention. This equation is actually proportional, and it has the 0, 0. Plus, if I were to do y over x, notice my numbers. What's 3 over 3? 1. What's 6 over 6? 1. What's 9 over 9? 1. I get the same constant k. Now, if I were to go try example 2, notice what would happen here. What's 4 over 3? What's 6 over 5? Just check those. Notice what's 4 over 3? And then what's 6 over 5? Notice that they're not even the same. These do not have a constant k, so I already know it's not going to work. I could check them that method, but let's say I go through my linear regression. So I'm going to change list 2 to my y's of 2 values. So notice the 0, 3, 6, 9 stays the same, but these values will be 0, 4, 5, 7. And I get stat, calc, number 4, and then it's the same process again except with different data. So this time my equation is that. So if I write this, it's probably not even 100% accurate, but if I write this, notice that first off, it's non-proportional. According to this, it doesn't even cross the origin, which the data says it does, but the equation says it doesn't. So I can tell you that this data is not growing proportionally. So I can do k equals y over x, or I can do linear regression. If I finish off the other two at linear regression, these are the equations I get. The only one that comes out proportional was Mary. So in this case, my answer is going to be Mary. And I could kind of tell from the beginning, but it helps to check the others. All right, last one here. In this case, we got a keyword. It says dilation. So which one describes the dilation? So the first thing to notice is, how does a dilation rule look like? It's going to be something like this. Scale factor x, comma, scale factor y. So hopefully y'all can tell that there's one answer here that's already super off, and that would be D, because D is actually a translation rule. All right, but here's what we should know. Aside from knowing that it's going to get bigger or smaller, we need to know two things about the scale factor. Every time we do a dilation, the scale factor is involved. The first thing I need you to know is that you use it as a multiplier. Now, in this case, I don't need to use it. It's already been used. I already see the dilation. What I need to do is find the scale factor. So how do you find the scale factor? New over old. Now, what I got to do before I figure this out is which image there is the new one, which one is the old one. So if you read on top, it says, let's see. So the rectangle shown on the grid on the left, the rectangle is dilated. Okay, so the one on the left is my original, and the one on the right is my new. So all I gotta do is figure out a new over old. Now, let's just say I pick these points. So I'm gonna pick one of my bottom corners, 10, -5. I'm gonna pick the corresponding old point, and I'm gonna just do new over old. So let's say I go with my 10, then I'm gonna have to use the 4. So what's new? 10 over 4 old. And then that would leave me with 2.5. Now, what I want to point out is when the dilation gets enlarged, your scale factor had to be bigger than 1. Only one of my options that I have left is greater than 1, so I could kind of already tell the answer. But the proper way is to do new over old. And notice that only one of these gives you the same scale factor. That would be B. It's also the only answer that's greater than 1 that would represent an enlargement. So you can do new over old, you can use your scale factor rules, and it doesn't even have to be coordinates actually. What I could do is I could also use I could count measurements. So keep that in mind. I could count right here the height and say it's about 12.5, and I could count the other height. What I could do is, what should work is, what's 12.5 my new height over 5 my old height? And if you go work this one out, notice, let's do 12.5. This thing lags a little bit. 12.5, my new height over 5, my old height, I would still get 2.5. So your scale factor works with any new over old. Right? Actually, let me emphasize, any corresponding new over old. I can't just use the height of one and the base of the other. They have to be the same corresponding parts. Okay, so this one, you kind of have to read all of it to make sure you get it. So just to be safe, I'm going to go in and read this to you guys. It says, a kitten weighs 8 ounces at birth. The kitten gains 3 ounces a week. The kitten's weight is represented by y equals 8 plus 3x, where x is the number of weeks. Then is the relationship between the number of weeks and weight proportional? So the equation that's created, I'm asking, is it proportional? And when I say proportional, we should know that that is a y equals kx equation. So if I'm asking you, is y equals 8 plus 3x a y equals kx? And I'm going to say, no, it is not. So is it proportional? No. So right now, what I know is that it is not proportional, so I can get rid of C and D. Because it says that that they are, but I know that they're really not, so false. So is it A or B? So A says, no, it is non-proportional, and B says, no, it is non-proportional. So they're both right as far as the first part goes. But which one finishes it wrong? A says no because it is not a linear relationship. And then B says no because it is linear with the y-intercept of 8. Now, if you know how your equations work, then you can simply choose B because that is true. Now, here's a quick and easy way to prove it. Let's just go and graph y equals my equation. So y equals 8 plus 3x. And, well, when I graph it, notice it's linear. It is linear. And I don't know if you can tell where the y-intercept across is where the line crosses the y-axis. You can actually see there that it does cross at the y-intercept of 8. Now, another thing would have been this equation. I can rewrite it like this. I don't have to, but I can. And we should all know that 3 is the slope and 8 is the y-intercept. So if you just break down your equation, it's there. All right, so moving on. A triangular prism has a base perimeter of 32 and a height of 15. What is the lateral surface area? So that word is on my formula chart. So let's go ahead and go there. So notice like the last formula I did was kind of actually the same thing. I want surface area of a prism, and then I'm going to focus on lateral. So I'm going to use the equation S equals PH. I like to put a little L so that I know it's lateral. And this equation is kind of easy actually, because P means perimeter and then H means height. And notice that I'm given the height and I'm given the perimeter. So all I got to do is sub in and I'm done. So what's 32 times 15? And if I go work that out, let's go to the home screen. What's 32 by 15? I'm looking for an answer of 480. So it comes out there nice and easy. The answer is J. Notice why I'm putting units squared at the end. Actually, these were actually hints for this was an area problem. So you always want to pay attention to those details. But pretty easy question, as long as you know what the formula means. All right, so number 3, which statement is true? So notice the keyword is function. So before I start, let's make sure we know what we're supposed to know about functions. So every x kid has only one y mom. And then from that, we're supposed to say that x cannot and y can repeat. Okay, so now that I've done that, let's go ahead and try these. A says the set of ordered pairs that describe a function must lie on a line. So is that true or false? And then I'm going to show you this. I'm going to show you with D first. It says a graph describes a function if no point on the graph lies directly above or below another point. So notice that is going to be true, because on a graph you have to do something called your vertical line test. And in order for you to pass a vertical line test, it cannot cross more than once. So if I just draw a vertical line right here, notice that it would fail because it crossed more than once. So that would be true. If that never happens, then I do have a function. Now, notice that this kind of takes care of A for me. A set of ordered pairs that describes a function must lie on a line. Well, you see, this example that I just showed you right now, they do lie on a line. They lie on a vertical line. And that is not a function. So that actually proves to me that A is false. Now, B says a table of values describes a function if all the y values are different. Well, that's also going to be false, because I just told you that y values can repeat. So if whether they do or they don't, it doesn't matter. The way I get a function is more on the x values. So C says a mapping is a function if there is the same number of x values as there are y values. And then that would also make no sense, because I can actually reuse my y values. I can repeat a y value. So it might look something like this. They don't have to be like that. I could actually use the 5 twice. So notice in this case, I got 3 x values, I got 3 y values, and this one's still not a function because the y's can repeat. So really, the only one that's going to be true here is D. All right, guys. So this is pretty much the end of it. I do want you guys to make sure you practice this. If you need to watch these videos more than once, do so. This is to help you retain everything that you guys might have forgotten, a little bit of everything all at once. Actually go through it. So when you guys return back to school, I expect that you would have already completed this assignment and that you will continue to watch it in preparation. Okay, because it'll be so much easier to review with you guys once you already have done the part of the review on your own. All right, thanks you guys for watching.